for today will be by George, and the title of the presentation is Streaming GNOME from GNOME for GNOME. George, whenever you feel ready.
I'm turning things on again. Can you folks see my screen? Should have a nice wallpaper in there. Okay. Probably yes. So let me open my presentation. See GUADEC. Execute this presentation. Are we good to go? Can I begin? Okay.
Yes, you're good to go.
Okay, wonderful. So I see there's 16 people here in the chat. Thanks everyone for coming. I am delighted to be talking to you about streaming since it seems to be a popular thing to do these days. So my name is Georges, and I am going to talk about streaming GNOME-related stuff from GNOME for GNOME people. So welcome. I assume many of you watched Daniel's talk yesterday about why you should stream, why streaming might be your thing, cool things associated with it, not so cool things associated with it, and everything about the social dynamics of streaming. It was a wonderful talk, by the way. If you didn't watch, make sure to watch it after this, in a break or after today's tracks are over. It's on YouTube as far as I know. And suppose you decided to stream now. You thought to yourself, this might be cool. I may want to stream about GNOME development in my mother tongue. So, I can create a community that not necessarily speak in English. Or maybe you want to, you want to showcase your cool project that you've been working on and nobody knew about that. And I don't know, anything. You decided you want to stream. What do you do? What do you need? How does it work? Is it going to be difficult? All these questions may pop up in your head, and they are all fair questions. Personally, I have been streaming for the past 3 years. It's in Portuguese, but you can see the number 3 down over here, and that's probably enough proof that it's been 3 years. Actually, my first video was on June the 1st, I think. So it's almost precisely 1 year. Oh, sorry, 3 years, 1 month. No, 3 years and 2 months. I don't know. Look at this pathetic face of a person who does not know what they're doing. You can see various problems in this picture already. That time, there was basically no Wayland support. The applications that we are going to be talking about, they didn't support Wayland. I am not aware of anybody else doing those kind of streams. Streaming GNOME development 3 years ago. There's a chance. Can you folks still hear me? Big blue button seems to be telling me I'm not connected anymore. Okay. Okay, maybe it's getting a bit crazy. So yeah, at that time, lack of hardware information, no gearing information, those fancy streaming accessories, nothing like that. It was a pretty bad situation overall. It was hard to, start. But these times are no more. Let's talk about the software that you're gonna need to stream. Fairly easy. We can start easy and small. You're gonna need OBS Studio. You're gonna need a music player, and you're gonna need a browser. Those are the 3 applications that you're gonna need to start streaming. OBS to do the streaming, music player for the background music, and and the browser to eventually manage the chat or anything like that. For OBS, what I do recommend you is to have 4 scenes: a welcome scene, a secrets, an ending scene, and one with your desktop or face cam. Welcoming is it's a bit pretty basic. While you're preparing yourself to start a stream, you just slap a welcome scene in there. Go simple. A black background with a white text on top saying stream about to begin is more than enough. You don't have to go fancy on any of that. A face cam is optional. Absolutely optional. You can stream your desktop content, you can stream your project, you can stream your stuff without showing your face. It's optional. The secret scene is one that I've learned the hard way that you may want to. Sometimes you have to put your password or you have to open your browser to do something, and it may leak some personal information. So it's super handy to have one scene with a hold on, back soon kind of message, so that you switch to it, do whatever sensitive thing you need to do, and then go back to your desktop. And an ending scene, which is a thank you message or come back later, things like that. This is the basics of OBS. It should be super simple, and you can set it up in 10 minutes. Shouldn't be a problem if you manage to find your way through the OBS Studio interface. Music. What can I tell you about music? Avoid copyrighted music like the plague, because they will come after you. And it's going to be a pain. The YouTube library is probably, if you go to studio.youtube.com, you find a library, a music library. That's a good starting point. Pick some tracks, download them, and use a music player to play them on the background. This is super important. I didn't pay attention to this in my first 2 years of streaming, well, my year and a half of streaming. And they carpet bombed me with copyright claims and whatnot. So now all of my videos have ads on them, and I'm not getting anything out of that. It's a pain. Avoid copyrighted music. Start with YouTube. There are other services you can use for background musics. I cannot give you any tips on them because I've never used them, but you will find many services for that. So about the streaming services, if there is one thing that I can tell you about streaming is do not ever look at the statistics page. These services, they profit from you getting hooked into increasing your numbers. So it is overwhelming, the amount of information, and it's a battle that you cannot win. You're always gonna be feeling bad about it. You always want to increase your numbers. Do not look at the numbers. It is going to actively harm your mental health. Don't look at them. Focus on having fun, having a great time, doing your thing, creating a community around you, interacting with people. This is the fun part, and this is really what you should be caring about. So you will find in many of my personal streams that I keep saying that I do not stream for YouTube. I stream for GNOME, and YouTube is just a medium. That's a mentality that has been working for me. And apparently, this is the kind of mentality that everyone seems to say that it's the correct mentality that you should approach this problem with. I stream for GNOME, to the GNOME community. I do not stream for YouTube. I do not stream for numbers. And thinking about them, it's a terrible idea. If you have social media accounts, which I do not have, I don't have Twitter or Mastodon or anything like that. But if you do have, you have the option to schedule your streams, get a link, and share them. This is good for engagement. People will find out about what you're doing. And if your goal is to, create a community and interact with people and just have a good time, it's good to let people know about what you're doing, so they can decide to go, instead of not knowing that you're doing and miss on that. If it's GNOME related, talk to the GNOME engagement team, because they can help you in there. This is basically what I have to talk about the software side of things. Of course, there are thousands of hours of video about how to set up your scenes, how to increase value with your streams, or how to find the perfect bandwidth and the perfect the perfect compression size and the perfect bandwidth size and all those things. You can give it a look at them. They may or may not help you. Stick to the basics, start small, and go figuring out problems don't. What I can tell you is that there's so much material talking about potential problems that you're going to have, that it's impossible for you to keep all of these problems in mind. So just, if you have any problems, search for answers for these specific problems. I'm not going to enter into the topic of optimizing bandwidth or anything, because it's an endlessly, it's infinite. We can talk about it forever, and nobody will reach any conclusion anytime soon. So now let's talk about the hardware part of things, because I wish I knew some of those things before I started. First and foremost, if you have I'm not gonna tell people to buy stuff, because you don't need to buy stuff necessarily to start streaming. It's super easy and it's super accessible these days. If there is one thing that I will encourage you to buy, is a microphone. Any cheap USB condenser microphone is going to be enough. People put up with bad video. People absolutely do not care about the video that you're streaming. If your audio starts to chop up, or if your audio is muffled, or if your audio is just bad, they are not gonna accept that they're gonna fly off. They're gonna disappear. People put up with bad video, but not bad audio. If you buy a cheap, like a $5 or $10 USB condenser microphone, it's gonna be enough for you. And I highly encourage this, getting one. Because if you get a decent microphone, a cheap one, you can add effects to it. On Knob Studio, or even like easy effects, you have, if you have plenty of possibilities to fix your cheap microphone. But if your microphone is doomed, there's nothing you can add to it that will fix it. Noise filtering is important. Ops has made that super easy. You can just add a filter, RNN noise, add it. No brainer, just add a filter in there and you'll be good. If you have a microphone and you want to increase the audio, the quality of your audio, there's lots of tutorials around the internet. Again, you do not need to buy a super high-end microphone, because the prices, they escalate super quickly. Any $5 or $10 cheap USB condenser microphone is going to be enough for like 95% of the people. Another thing that seems to be a common topic when talking about audio on streaming is audio interfaces. They are not required. You do not have to buy one. You don't have to use one to get good audio quality, but it helps. If you don't know what an audio interface is, it's basically this thing here, where you have inputs. In this case, I have two inputs. You plug your microphone in here, or maybe your guitar, and then you have outputs like phone, or on the back of it has outputs for audio. This helps, but it's not necessary, and it can be tricky to find one that works on Linux. If you have some budget for one, I advise you to buy a spec compliant device because, like, for example, this one has tons of features. You can see, I don't know if my video quality is enough, but you can see that there are some air and pad and inst. There's some stuff for which it does not have buttons to control because these things are controlled by software and the manufacturer does not provide software for Linux. My rule of thumb is that if you're looking for an audio interface and it claims to have features but you don't see buttons to control those features, avoid it because it's not going to work on Linux. About video, don't obsess too much about it, especially webcam. It's optional. You can stream without your face, or you can do some VTubing. You can stream with I don't know, a character. I never tried this, but people can try that. Any popular Logitech model is enough. They work perfectly on Linux. Like literally, almost literally, any popular model is gonna be enough for like 95% of you, if you have the budget and you want to show your face, of course. The secret is using LUT filters. They massively make your webcam look more cinematic, you know. Lights, it's good to have lighting. Like, for example, I don't know if you can see my cam there. You probably can. But I turn off all the lights and I have one ring light in my diagonal here, and it creates shade on the side of my face. It creates depth. It looks pretty good. It's decent. On the background, I have one super cheap, I don't know, where's my finger here? I have one super cheap RGB light. Like literally anything you do is gonna be fine. Start with a little pitch black room. Open your camera, turn off all the lights, close all of your windows, and then go one by one, turning each light individually and see how it looks. It's super easy to figure out what's the appropriate lighting for your room. The background, like, just don't do anything. Or if you do, literally any detail is enough. You don't have to. These things can be super costly, and they are not necessary, you know, and they don't add too much value to what you're doing. So don't spend too much time on it. And at last, we have the streaming gear. We got Stream Decks, which is like the bread and butter when you talk about streaming. Fortunately, we have support for this recently. We gained support for these hardware. Here's proof that it works. It integrates with Op Studio, and you know, nowadays you can have a decent experience with Stream Decks on Linux. There's other Elgato gear, like the key lights and whatnot. I know that there are shell extensions and maybe even apps to control them. But if anybody has any contacts with in Elgato, let me help you, because I want to. I don't have the hardware to test this, but I want to make the streaming experience more better on Linux. Recently, there's been those Razer Stream controllers. It does not work on Linux yet, I'm sorry to say. Does anyone know of any Razer folks that I can talk to? Because I want to make that happen on Linux. And there's GoXLR. It does not officially work on Linux as far as I know. And sadly, communications died out. I wanted to get them done, get them working on Linux. Seems to not be happening anytime soon. Do you know of other streaming gear that you'd like to see on Linux and I did not mention? If you do know about it, let me know. I have personally a goal of making streaming on Linux a better experience than on any other platform. So if you know about any other streaming gear, ping me. And yeah, that's basically what I have to talk about streaming. Essentially, this is what you need to do to get started. If anyone has any questions, Now it's the time to ask them. I see that there are, right. Definitely. Yeah. So my mother language is not English. My mother language is Portuguese. But streaming in English has absolutely helped me getting more comfortable with speaking in English. I do stream in Portuguese eventually. And, well, the discussion about the language has already happened during Daniel's talk yesterday, which I again recommend people to watch. Um, Streaming in Portuguese is super comfortable for me because it's my mother tongue. Speaking in English is, I was terrified the first times. I was like scared to death. Now I'm super comfortable doing that. Um, yeah, it has helped me, and it is one side effect of streaming. Um, you put yourself in a public position, and it can help you getting more comfortable being in this position.
About programming help the GNOME project doing streaming?
Ha, that's a good question. So, yeah, this is interesting. You can start podcasts on your native language. You can write documentation if you know English. You can, create a sub community within the community, like a Brazilian Portuguese community, where you talk about everything you know, or everything about your favorite topic about and talk to people. And you know what? People get together. Like people enjoy interacting with others. And there's plenty of ways, like writing documentation. You know, Basically everything that requires more than one person to do is a candidate for streaming. I know that Jakob does art streams. Like, Jakob does not program. Jakob just uses Blender and Inkscape and does art, and sometimes work on websites, CSS. That's um, that's one example of non-programming, um, non-coding streams. Yeah.
Great, thank you. And we have the last question. How can I make sure that the content is not boring?
This is super simple. Is it boring to you? If you're doing the stream and the content is boring to you, just don't do it. If you're doing the stream and you're excited about what you're doing, that's the only metric of boring content. In my experience, people get excited about what you get excited, no matter what it is, truly. Some topics may attract more people than others, but in the end, it is your excitement that determines if the topic is exciting or not. And I'm not saying that you should like be super hyper positive and energetic. It's like, if these things, they they are visible, they are subtly visible throughout the stream. You're you show your passion for something, and people get together around it. It's that simple. Emanuele seems to be saying that getting angry on stream about something that you're doing is also very good at driving engagement. Yeah, uh, I can I can concur. I can say that it happens, and you get super frustrated about something, and that seems to get into I don't know. That seems to be an spectacle for a lot of people. But yeah, on 90% of the time, you're gonna be passionate about what you're doing, not angry. Yep.
From the audience, and we'll be
Sure.
done. Just a question.
Hey, Georges. This is Scott. Hey,
Hello.
question about the one thing that I wonder about is tempo. when you present, do you slow down and say things, or I know a lot of people when they're watching talks, they'll play them back at 1.5 or 1.8 speed. So do you think it invigorates the audience more to speak faster, or do you feel like that overwhelms the audience? Do you just go at a normal pace? Have you ever considered, tempo?
Hmm. This is interesting. It depends on the content that you're doing. In my case, I usually do live programming, and sometimes that requires deep thinking, and there's not a lot of motion in doing that. There's not a lot of there's not a lot of talking even. And in these cases, the stream acts more like a co-working space. People put their stream, I don't know, on the television or on the secondary screen and go do their own thing together with you. But I also have some experience on kind of, how can I put it, more entertaining kind of streams, in which I talk about the latest developments on GNOME, or things that are happening right now, or just talk about philosophy of free software and things like that. And on those cases, the tempo gets higher. So it kind of depends on what you're doing and what do you expect from that. So it's impossible to be super entertaining when you're doing deep thinking, for example. But that's fine. That's the content that you're doing. That's the I don't like using content actually, but that's like there's no other way to do that properly without deep thinking. So that's expected. Hope that answers your question.
And this is the end of your presentation. We will meet in 2 minutes with our keynote. Thank you.
You can find this presentation in my GitLab if you want to. It's on gitlab.gnome.org/general. This one. So yeah, thank you very much for coming in for the questions.
Hi, good morning. Good morning, everyone. So thank you so much for being here. Um, Evolution of GNU toolchains and its importance in open source. Let me see. You know, a few weeks ago, we saw the amazing first images from the James Webb Telescope coming out from NASA. And they were amazing. Actually, my 7-year-old daughter and I was watching the news, and it was impressive. And she came up with a simple, basic question to me that was very interesting to think about it. And she said, Dad, let me see. There you are. Why we need to create new telescopes? And I was like fascinated with the question. It was a very basic question, and say, well, we were watching this image from 1990s and 2021, and she said, well, it looks alike. Definitely the one that is new looked way much more beautiful, but why do we need to create new telescopes? And when I was doing these slides, came up to me the same question. Thank you. Why do we need to create new compilers? Compiler has been existing. Actually, GNU was released in March of 1987, same year that I was born. Yeah. And it was funny to me to say, hey, there are so many books that has been created for compilers. Since the first version that we have, from the like regular Dragon book compiler to modern design compilers, the first release of GCC, March 22, 1987, to the latest release that we have last May of this year, many things has changed. But the question is, why do we need to create new compiler? And the question is again, why do we need to create new desktop? Why do we need to create new genome every year? Every year we create new things. Pretty much, when we see what is a tool chain, in software, a tool chain is a set of programming tools that is available for us to create new complex software. How do we debug that software? So it's a bunch of tools. Literally, it's like you going to a workshop and you try to create something. It's all the available tools that you have over there. Now, tool chains for us, it's based on some of the things like, okay, we have the compiler, we have the assembler, we have the linker, and we have the loader. Each one of those, actually with the debugger, has its own project. We have the specific GCC, we have glibc, we have bin utils for binary utils to do the assembly and so on. We have the debugger with GDB. All these things goes into the flow of a regular compiler and so on in order to create a new binary that it's available for the operating system to execute as a process. Inside it could call forks, execs, many things that you want. what we have built all these years, 35 years. Well, GNU toolchains has been able to create genome, for instance. We have been able to create operating systems, image process libraries, web servers, kernels, anything, right? The GNU is very, very, very proud to say we are the core system that helps to create from Mozilla to the kernel, going through the genome desktop, going through the libraries, anything that you want, it's pretty much built. We are very happy to have more communities. LLVM, they are a good friend of us. We are very happy to have Muslim because it's a new way that in open source we create new technology. We open the frontiers to say, hey, let's gonna create a different project that try to solve the same problem in a different way. But yeah, we're proud of what we have created as a tool change. Now, let's take a walk through to the latest things that has been in GCC, GNU about different topics: security, performance, developer experience, and some of these are well known, some of those might be new for you, but it's an evolution. A static analyzer. Pretty much in a static analyzer, you can use an external tool for sure. You can buy any tool, you can use open source version, you can use anything you want for a static analyzer. Is it part of the development that we have today? Yes. Is it useful? Yes, very much. Why? Because it helps us to detect security issues, it helps us to detect logical issues in our code that human eye, despite the fact that we could have a huge community of friends trying to figure out, yeah, there might be some holes that we're not watching at this. And also it's the first tool that we can use to defend against those kind of things. David Malcolm has been the main brain about the project that is the static analyzer for GCC. Has been developing this since GCC version 10, 11, and lately in 12. It has been a good evolution. And yeah, there has some been good things and things that, well, static analyzer could improve. The first thing is that, yeah, it finds weakness in the code at the exact location. Then it allows to quicker turn around the fixes because it's also proposed a new fix for your code. It could be automatically put into your pipeline, right? And it allows us to find security vulnerabilities easier and sooner that actually release the product and said to our friends from QA, hey, could you please test this binary, this application? We can detect those things first in the development. Well, it's time consuming, definitely. Is it not perfect? Also. Do we have false positives or false negatives? Also. But it's, as any other tool, things that we are trying to develop all together as part of the community. And definitely, it does not find vulnerabilities at runtime. Let's start with this simple basic example. I know it's ugly, it's the worst code in C that you can imagine, but it's just a basic idea. What is wrong with that code? Yeah, you got it. So when you try to print over there, X is not going to be initialized in that. And we have a new way to say, hey, may I have a warning? And by the way, you just need to set fanalyze in the beginning of your compilation with GCC latest version, and it will detect actually this kind of behavior. But not only that, it would also print you this. It will tell you, no, actually int x, it's uninitialized value of x here. And guess what? You have a CWE, which is 457. And when we go and check into the database of vulnerabilities, we will see what kind of other CVEs are related to that part. So the compiler not only tells you, hey, we have an issue, but also it's going to tell you that this is the kind of vulnerability in security that you might have, and it's the kind of issues that you might be facing. Pretty much what we can do, it's very damaged. Attacker can sometimes control or read these contents. In C, it's very, very bad to have uninitialized values. It's very warning for us as a compiler. And this is the list that when we go and check that CWE, these are the CVEs that are related to that. I was trying to find some of the CVEs related to this in Genome. Thank you so much. There are very few. I was not able to find like that huge amount of uninitialized values in GNU projects. But yeah, it's a good tool about this. What about this code? at first sight, we said we have a pointer, we're trying to do a malloc of that, create a buffer, and so on. But when we compile within a specific flag, thank you. So uninitialized value also for the pointer. So there is an initialized value over here, and it's pointing, by the way, the same kind of errors that we're detecting in the exact line of code that it's happening the problem. And the kind of a buffer overflows, because now we have a buffer that it's not initialized, we could have buffer overflows. It could be used to execute arbitrary code. Actually, we will see that in a few slides. Another kind of issue that is the ROP attacks. That good is that many architecture are creating special instructions or shadow stacks to go against that, and the compiler provides a way to actually fight against those things. But the good thing is that the static analyzer will be able to detect this kind of vulnerabilities and say, hey, developer, please fix it, because these are the kind of bugs that you might be facing. You can watch those and see how did they fix it. There are one from 2021, which is very, very, very recent. Let's go with overflow attacks. There you are. FCF protection, it's a new flag that has been integrated since GCC 8, so around 4 years ago. And there are many kinds of security attacks that we could prevent with this kind of flag. The first one could be the return-oriented programming, ROP, or we could also have polls, jumps-oriented programming, COP, GOP attack. So how does it work? Let's see this code. Looks straightforward. Even when you compile with regular compiler, not even applying a specific flag, scanf, it's like horrible. The compiler will cry from inside and outside and say, please don't do that. Because scanf is like super banned from the development. It's a huge hole in security. The compiler will literally cry and say, please don't do it. Now, even if the developer, like in my case, just for didactic purpose, said, I'm going to use a scanf for get the password. And thank you. And there is a secret function, as you can see over there, right? So in main, I only call echo. I declare a buffer of 20, and then, okay, enter some text, and I will just print it. There is no logical way that I could arrive to secret function. Right? In the logic of this code, it's impossible to actually go to the secret function. Now, the problem is that I had a scanf and I have a buffer over here. Those two, it's the perfect combination to have a pretty bad overflow thing. How can we exploit that? Well, let's see. There you are. Yeah. So the first 28 bits plus 42, it's going to be the bytes that are going to be available for when we reserve for that buffer. The problem is that when we move to a new function, and by the way, this is compiled without randomly generate the address and so on. So it's very, very bad compilation, but it's possible to just for didactic purpose. You save in your stack from where you came in that function. So the echo function is going to say, oh, wait a minute, I came from main. So when I finish with my echo function, I'm going to come back to the main. So I save the address where I need to come back. That's the reason what is return-oriented attack or ROP attack. Because when we assume that, say, hey, I'm going to return back to my function, it's actually the address that we're going to override by a buffer overflow to point to a completely different thing. So the thing that I did over here was, let's say, okay, I'm going to create a huge string. That's the reason why I use the import struct C print multiple A's, whatever, garbage. The A could be any other value. But the last thing, it's actually the address that I was able to figure out from the object dump of the binary that I have this bool. And I know that writing in the data specific position, which is 32 bytes, I could put the address. Little endian or big endian, whatever your architecture is, but you can put that thing in that format. So we enter 32 A's, and at the end we have the address, and that's what we enter as a text. And what happened is that it goes, as you can see, to the secret function, But this is because we have over here the address, in this case, it's 8004 into the stack pointer. And the program counter is going to say, I'm in read. So when we override these to a specific pointer in memory, where to go, the stack pointer will say, I finished with the read. Somebody write over here the wrong value, which is the hack thing. And when we said, hey, okay, come back to the main, it will come back to this address, which is way different from the main that I have. So it forced to override to jump to another point. The bad thing is not that you jump to a function that is not supposed to be. The bad thing is that over here, it's possible to write a specific assembly code to do anything that you want. There are some web pages which is very fun for PhD research. They save in a web page in hexadecimal format things so that you can execute bash. So when you attack with the buffer overflow and you pass the specific chars, hexadecimal chars, you can actually convert into bash. And since it's being executed by kernel, it will have root permission at that perspective. So it's very bad thing about security. Now, FCF protection, full branch return or not, that's a branch that has been enabled in GCC since 4 years. The good thing is that more architectures are being enabled. In the beginning was x86. Last LinuxCon, I saw that IBM it's also enabled, and more architecture are coming. So how does it work, the protection? Let's see. So we will have two ways to protect, a shadow stack and an indirect branch tracking in x86 platform. So the shadow stack is going to be like a second stack only used to call and return instructions. When the call instruction is executed and the address is coming back, we will compare, right, to see if we are coming to the same point. If it's not the same point where we're coming to say, hey, I was coming from main, what are you asking me to come back? Oh, some other address. Actually, the address does not match. So let's generate an error, cancel the process. It's exit from here. It's a security issue. And the indirect branch tracking, it's a new instruction to set, I'm going to mark valid jump started address. We're going to validate the address, it's okay. And if it's okay, I'm going to come back. But actually, it's only enabled in some x86 platform. If it doesn't exist, the compiler is just going to set bad and just do a NOP execution of instruction. What about performance? Okay, so F-loop interchange, one of my favorite flags for performance improvements. So let's see this little code. In this code, we have simple for. One is go from 0 to 99. The other ones go from 0 to 999. And inside it's doing anything you want, math operation, a string comparison, whatever you want. So F-loop interchange is going to say, wait a minute, is it optimal for the cache? Because we as a developer, we could say, I'm going to code that. And I don't care about the hardware, which is fine. But the hardware is there. And the organization of the hardware in terms of memory hierarchy is this. We have the memory. We have the CPU. Inside each one of the CPUs is going to have a cache. And look at this. This is the funny thing. If we follow what we want in software, we will have from 0 to 99, from 0 to 999, and it will go, look at this. Let's going to pay attention over here. So we have 0, 0, 1, 0, 2, 0, 3, 0. The problem is that in memory, it could be a range difference. In cache, we could have 0, 0, 0, 1, horizontal perspective. And each one of the cache line is going to read that part from 0 to 999. The second line of cache is this one. But what we're looking for, it's a different organization. We're reading in a different perspective. It's the same information, yes. But we will read the full line of cache, read just this value, and discard the rest. So the cache is going to have to go again, read another line, and discard the rest. Go again, read, and discard the rest. The amount of cache requests that we do, it's huge. Now, what happens if we literally change with F-loop interchange? Well, this is some memory facts. When the processor accesses any array of elements at first time, it retrieves the entire cache line of data from main memory to the cache memory. If the rest of the data will be used soon, this is a major performance boost. If, on the other hand, the rest of the data is not used, it's definitely a performance loss. So what happens when we do F-loop interchange? F-loop interchange will detect that and say, you know, actually the performance goes better if we just change the loop, the order of the force. And in that order, we will go to 0, 0, 0, 1. So it matches with the cache line that we have over here. So the memory controller is optimized to actually read the full cache, and instead of waste all of that time that you go into memory. And remember that when we go into memory, it's an install cycle. Because in the middle of the pipeline, we have instruction fetch, instructions decode, execution, memory, and write back. But in the memory, if it's not there, we have to wait, and the pipelines suffer in the middle of the CPU. F-profile partial training. It's one of the most amazing features that we have had in GCC. Okay, so how does profiling work? We have the compile, we have the profile execution. Let's talk about a little bit of profiling. Imagine that you are managing a kids team of soccer, and you want to know who of the kids is playing better, who of the kids is not running that much, or what's the best position for each one of the kids, or even if it's not kids, if it's grown adults and so on. So you're trying to coach a sport team. So in the TV now, we can see, oh, that player actually runs all over the place and goes very fast and so on. Okay, that's his side. But we can see from the field that that player, it's actually moving to the left or in the middle or always in the back and so on. So it's an analysis of where each one of the players is going and when it's spending more time. Profiling in the compiler, it's pretty much the same. So in order to pursue a better performance, the compiler is going to try to say something. You know, I received the code as a compiler, and you asked me to create the binary. Yes, I can check lexical, syntax, semantic, and so on, and in the middle, generate an intermediate or language, generate the assembly, and then the assembly language, and the assembler is going to actually take that to generate a binary. But there is one section, which is the performance optimization. Sorry, let me go back here. Here you are. And in that section, the compiler is free to decide what to do in some cases, like where to put that function. Should we put that function way too far? Should we put that function way too close? How do we arrange the section of the text code? Where do I put that thing? So the compiler doesn't know at that perspective because it hasn't executed the code yet. What we're going to do is to say, hey, there are some ways to say, okay, I'm going to compile with the proper instrumentation, meaning counting how many times when I execute the code, did I pass for each one of the function? Did I call each one of the ifs and else of the branches that I have inside the code? So, and I'm going to later like profile the execution and recompile again with the known information that I know. You know, actually, I know now that if else, it's never taking the else. So it doesn't matter if I put that far, far away, or if I do not optimize that part, always the branch goes like this. Okay, so we could have function A, function B, and function C. And if function A it's not executed during the train, because in this part you need to be way smart to say, okay, I generate my binary, I'm going to train in the usual way that I have for a specific application that I know that it will be the most used. So that's human part. And if the profile execution is not execution that function, that part, it doesn't save any information. If instead function C, it's executing during the train, we will optimize just that function. And the other functions, it's going to be optimized for size, because this could increase the size or not, but generally does. And the other ones, we're going to decrease the size to keep the health into the binary. Yeah, the compilers do performance optimization and decide what branch to do. Profile guide optimization is the method used by the compiler to introduce the best code. And the profile guide optimization, it's an instrumented binary that you will recollect information of what you're doing during the execution. Now, how does it work? You said GCC F profile generate, and it will provide, you specify the directory, you have your source code, you execute your binary, and then you set GCC F profile use instead of generate, and it's going to use the information that it's saved over here. So the compiler is going to read that information, recompile the source code, and generate a better optimized performance. What kind of optimization can we expect from there? See, there you are. Function inlining. It's a technique where we inline high frequency functions. So let's see, the function A, it's going to call 30 times or 30% function C and 70% function B. And actually function B, it's going to time 80% function D and 20% function E. Same with FG, 90 and 10%. So they inline the high frequency function into one calling function to reduce the function calls overhead. So they said, put all these as if it will be a function, and remove the other ones because or put it far away because it's not going to be highly used. The percentage it's high over here or over that path. Block ordering. The compiler is trying to achieve call locally or perform minimum of memory operations. So instead of saying, okay, actually, I'm going to do a call to A from C and from B to C, actually what happened if I put C closer to A and I put B closer to D, which D is going to be called way many times. So they reallocate in memory the functions so that the jumps inside the memory of the binary is way minimal. And that code elimination. If it detects code that is never being executed, and that's very dangerous. Some people like, I don't want that code elimination. Well, that's something that we can change. It's similar to FDC, but with runtime information, by the way. It's an already known flag from the compiler. Developer experience, and that's super fun. Actually helped me still in the morning, Monday, without coffee. So hello world, and you define a variable that is color, and you put an extra color into your variable. When you try to compile that with fdiagnostic perceivable fixit, that flag is going to tell you, actually, it's not that ugly thing that you have over here. Your variable, you might set this color. And the good thing about this is that it's not only smart to detect this kind of, by the way, it only provide you like a hint. It's a machine, it could still commit mistakes. But also, fdiagnostic generate the patch in a Git format. So imagine that you have a big project like Genome, and you want to compile some of the codes that you have been creating, and you see all over the place bugs that like typos and so on. So once you detect that are typos and you don't want to spend time fixing them, you can generate fdiagnostic generate patch. And there are two ways to generate the patch, or in a text way or in a JSON way. So fdiagnostic format equal JSON also can be generated like, I just want to read the report of what were the errors. You can generate the patch to me, but before I want to understand what were the errors. So you can generate the way in text format or in JSON format. And of course, we can imagine like DevOps can take the JSON, create pretty reports in the pipeline and say, hey, actually, for this release, we have discovered these kind of bugs in terms of typos and so on. We already have a fix, but hey, Monday morning when you arrive and see a dashboard of the project, you can see, hey, so actually it is very easy to fix. How can I test new tool changes? Some people think like, hey, it's super horrible to test. I need to wait for my operating system to support it and so on. Yeah, thanks a lot to the operating system because they test the new version of our tools, of our compiler, of our glibc, GCC. If we want to go with the latest and greatest, it's very simple. So in the slides, there is a basic bash script that you just download from there, the latest release, GCC 12, by the way. You compile, it's a simple makefile. There are some flags that if you want to just test C, just say enable equals C, just say disable multi-arc because you're just building for your architecture that you are, and so on. So in the end, inside your directory, you're going to have GCC for C, for C++, You will have object dumps when you compile bin utils and so on. And it's very simple. Just a gcc dash dash version, and you will see that you're using or not the latest version. And that's it. So it's not that complicated to use your own compiler that you compile on your custom IDS, waiting for, of course, your operating system support it. So back into the point of why we need to create new tool chains. New tool chains came to the same question. Why do we need to create new telescopes? We need to create new tool chains pretty much to discover better ways to create security, to discover better ways to find performance optimization, to discover better ways to actually develop new projects. We create new desktop also to create new ways to arrive to the desktop on the user, to create new ways to create an access to window, to create a panel, anything. That's the reason why we do open source, to discover new ways to create a technology that we love. And from the heart of any Linux developers, thank you so much, Genome, for 25 years anniversary, and we're very happy that you're over here. Thank you so much.
Do we have any questions from the audience? No? Okay. So let's go with the questions we have from our online audience. Okay, so does the new compilers helps to avoid all cases of or OP attacks? Do you know if the compilers have the capability?
Yes.
Or just GNU compiler?
No, the latest compiler since GCC 8, if the compiler is GCC version 8, it will have the capability to go against ROP attacks for that perspective. You just need to compile with that specific flag, FCF-protection.
And we have only one comment that says GNU did definitely not create GNOME. We just had the comment here and the. Let's see if we have anything else. I think that's it. So the last chance for any questions? Okay.
Hi, I think the question was asking about other compilers, not the GNU compiler. Do other compilers have the capability?
Sorry, thank you. I don't know if LLVM. We had a chat in Linux Plumbers 2015 with LLVM friends, and they were very close to many of the things that we were developing in that security part. Yeah, I know because I was in LinuxCon a few weeks ago, and ROP attacks has been enabled for Shadow in other architectures, IBM, PowerPC, and so on. So I assume that it will be also supported, but I don't know for sure.
Thank you. Anyone else? Yeah.
Hello.
Hi.
Does the inline keyword still make any sense in modern GCC? You're supplying it manually, this hint, to inline the function?
Again, please.
The inline keyword for functions.
Huh?
Does it still make any sense to supply it? Because you told us that the compiler more or less automatically detects these cases where it would be useful. So does manually writing inline for those functions where we believe it would be worth, does it have
for the presentation is over. For the PGO optimization, for the inlining?
Yes.
Oh no, it does, the compiler does by itself. So you instrument, you run with your test cases, the test cases that you want, it learn or it increment the numbers to say how many times each one of the function has been called with the test, and that information came back, and the compiler, when we recompile again, learn, and they generate a new binary by itself. So we don't have a way to say, hey, inline that way. No, it learns with, we need to change the test cases.
Okay, but if we don't supply that that option of PGO, the compiler does.
The compiler does by itself an organization of performance optimization without knowing about heuristics.
Oh.
Like base it on the logic of optimization that they have. There are 3 different levels, well, more, but we have O0, no optimization, O1, O2, and O3. By the way, there is a tricky. If you put O4 or O99 or O200, it's the same as doing O3, and we have requested that to remove from the main line, but they said that is a good joke. So, because people still believe that O200, it's optimizing way too much. But no, when you optimize for each one of the levels, implement the kind of optimization. For example, F-loop interchange is not enabled until O3. And this year, vectorization for single instruction multiple data, the huge registers from Intel and AMD and other ones, came by default in O2, not in O3. So when you compile with minus O2, it will have vectorization. If you don't want it, well, let's remove it from there when you compile. But yeah, it depends on the kind of optimization that you have. Inline, it's part of, I think, that O2. I don't remember top of my head.
Thank you.
Yeah, welcome.
So the shadow stack feature that requires hardware support, does it?
Which platform does it support?
Yeah, so the shadow stack is a hardware feature, isn't it?
It's no, the only hardware feature is the IBT, the instruction. The shadow stack has no relation with that in terms of hardware feature. For ROP attacks, there are 2 kinds: shadow stacks and the new instruction that it's available.
Okay, but so the shadow stack is a pure software implementation.
It's a pure software implementation from that part, yes.
So what's the performance impact there?
I don't have the number for performance impact of shadow stacks, because since it's a security, I haven't seen anything in Phoronix or anything relating to performance for shadow stack.
And if it's hardware supported, then is there any kind of performance impact there, or?
There is a performance impact for sure. Talking with HLU from glibc when we were testing this part from functional perspective, there is a performance report. Actually, I think that the patch that HLU was sending to glibc was showing the numbers. I wouldn't claim if it's high or low, but definitely change.
Okay, thanks.
No, well.
So, anyone else? No. Okay, thank you very much, Victor.
and learning about the board of directors and the opportunity to ask any questions to the directors or the foundation staff team. So I'm Rob McQueen. As of yesterday, I've been reappointed as the president of the foundation for the coming year. And this is Neil, who you all know. He's the executive director of the GNOME Foundation and in charge of the staff team. So, next slide. So we have Tybalt in the cloud, and he will be operating the slides because it's easier than passing the presentation backwards and forwards. But just as a quick agenda, we'll just start with, welcome, this bit, some introductions to the new directors who hopefully are somewhere on the conference, but we might be able to see them at some point. I have a very brief report just to update, and then I'll be handing over to Tybalt, who will be giving us some details about the strategy that the board has been working on and will be launching over the coming year. And then we'll hand over to Neil for finances and his report from the staff team. So just quickly over to introductions to the new board. So we had a fiercely contested elections, and the 4 candidates were appointed into the 4 posts. So we have the continuing directors, Philip and Regina, myself and Tybalt, and newly joining the board, Martine, Jeremy Allison and Sammy Fung. So thank you for everyone that's joined the board and has elected to help the foundation this year. And next, a thanks from the board and from the whole foundation to those who've served in the board and as officers last year. So Sean McCants has stepped down as many patient years as treasurer. He used to be a director and was a treasurer and then escaped, and then we reappointed him and he gladly accepted for quite a few years. So thanks especially to Sean. And thanks to Alberto, Felipe, Kat for their contributions and support of the board in the past couple of years. Annually, the board meets to have the board's annual meeting where we appoint the officers and the committees. So the officers perform specific legal functions in the GNOME Foundation, which is a corporation, and they're set out in the bylaws and California corporate law with certain responsibilities. So the president is basically the kind of manager of the board and keeping the directors in line and making sure that Neil has consistent directions from the board about strategy and priorities. So that's me. Vice Presidents Jeremy Allison and Regina are basically deputies to step in if I'm unavailable. They can continue with those kind of board organisation functions. The chair, Tybalt, who we'll be hearing from shortly, is responsible basically for running the meetings and setting the agenda and making sure that the board kind of internal communications are working effectively. And previously we had Alan Day as the chair, and I was working with him as president, and we were kind of a good kind of tag team, which I've been really enjoying continuing with Tybalt. Treasurer is responsible basically for overseeing the finances, signing the accounts, those things. Sammy has some existing financial experience and has agreed to work together with Rosanna, who's in the foundation team, to take responsibility for our finances and signing the tax form and that kind of stuff. So thank you to Sammy. Philip Quento is continuing as secretary, so minute taking and making sure that at least we have internal records and also public records of what the board discussed and why we've made the decisions that we've done, so we can help to go back and remind ourselves what's going on. And that's actually probably the most hard work of all of the officer roles. So we're glad to have an assistant secretary in Martine. So yes, thank you to the officers. We have quite a few committees, and I apologize, but probably just for convenience, I'm not going to read all of the names here because these are very similar to previous years. But we created over the past couple of years the Circle Committee that's responsible for deciding which applications are admitted into GNOME Circle as a kind of wider ecosystem of apps that use the kind of GNOME technology and ideology. The release team is responsible for the kind of the core of GNOME, deciding what makes up the desktop when it's released, you know, which libraries are included in our platform and those kind of decisions. Travel Committee for approving reimbursements for travel to events such as this one and the parallel event in Berlin. Membership and Elections Committee is to do with deciding who is eligible through their contributions to GNOME or the Circle applications to become a foundation member and who can vote, and then running the elections. And the Code of Conduct is responsible for basically maintaining the Code of Conduct and the rules around people's behaviour and expectations in the community, and dealing with any complaints or issues that are raised. So thank you to all of our committees. We have also added in the past couple of years some what I'm calling board committees. So those ones are kind of more sort of GNOME-based. These ones are more kind of foundation-based. The executive committee is temporarily a little bit larger because we are sort of preparing for a transition as Neil leaves his role as executive director later in the year. So we're temporarily adding Rosanna into the executive committee to kind of maintain continuity and make sure that the president and the chair and things have good visibility on what the staff team is doing. So it's normally supposed to be a little bit smaller than 5 people. Finance committee is basically just keeping an eye on the accounts and reporting into the board financial issues and finance policy and things. And the governance committee is around kind of monitoring and improving the way that the board works, the skills of the directors, whether we need to do training, recruit different directors, change the bylaws, and those kind of things. So committees. On now, I think, to President's report. I don't have too much to say because I'm actually going to hand over to Thibault for, I think, one of the more kind of exciting bits of this. But just to kind of quickly run through just kind of where we are. I mean, I think, long time AGM attendees will know that we've been kind of working through this, I think, kind of strategic journey for the foundation. We've had the opportunity of various large grants to kind of set a new direction and to decide what role the foundation would play within the GNOME community and within the wider ecosystem. And we're kind of taking quite an aggressive stance to use the money and start kind of blazing a trail and actually define, okay, the foundation is going to do more, and what impact are we looking for, and what is our kind of guiding logic behind that? What's the mission that the foundation is trying to deliver? What's the strategy that we think, this theory, if we do this, these things will happen. If we do this, this will get better. And we've been kind of working through that, I think, a little bit slower than I'd like. Each time the ideas get clearer and we get closer to kind of action and being able to execute things. And I think the very exciting thing is now this year, we're at a phase of actually like launching some of the boats. We've kind of figured out over the past couple of years, we've kind of refined from, okay, a mission or like a theory of where the foundation sits, with the GNOME project and the community and with the wider kind of non-profit ecosystem. Over the past year, we've kind of refined some ideas like, okay, actually, we can in practice do this thing and that will have this outcome and we'll contribute this to GNOME and we'll take GNOME into these new places in the world. And now we've got, 2 or 3 ideas of what we'll actually do there. This year, it's like go time. It's time to actually like write some grants and find some funding and actually do some stuff. So I think it's actually quite an exciting kind of turning point to go from maybe a bit more planning, a bit like what's Rob talking about? He said the same thing last year, like is FlatHub open yet? Like blah. Okay, let's do it. So there's a lot of kind of excitement now to just actually start some of these things and to get these initiatives actually up and running. So we're kind of looking forward to applying for grants and actually turning some of these things from theory into practice over the coming year. So just looking back at the past year, a couple of things that we've done kind of inside the board. I think just the strategy is probably the biggest thing that we have done. But next slide. We made a change to the bylaws, which is something that we've been talking about for close to 2 years, around essentially opening up board membership to people who are not foundation members. Because we noticed there was a bit of kind of circularity that becoming a foundation member was through project contributions, which kind of selects for certain skills within the open source community, whether that's design or engagement or development or documentation or translation or those things, not necessarily selecting for non-profit governance and fundraising and some of those things that, in a sense, the foundation needs more of in order to kind of boost its role in the community. So we made a change to the bylaws that, with some safeguards, it's possible for outsiders to stand for election and then at least go through the membership as a kind of a check as to whether these are people that we'd like as directors. We've been working on essentially just making the board a bit more effective internally, so kind of relying more on GitLab and issues and trying to prepare the agendas ahead of time so that the meetings can be very focused and efficient. Sometimes that works, sometimes it doesn't. I think probably this meeting this week on Tuesday is an example of it not working, but we're getting better on this, and I think that helps directors to make effective use of their time and hopefully improves the quality of the meetings and the quality of the oversight that the board is able to offer. The next slide. we've been working sort of behind the scenes, a bit with me, a bit with Neil, a bit with Tybalt, on just facilitating various kind of ecosystem and partner conversations. We've been running down a couple of things with Google and just kind of understanding, the kind of terms and situations around GNOME Online accounts, and how do we keep it working this year, even though the API of libsoup has changed and broken the entire world. And then what should we replace that with to kind of better meet security requirements and kind of the user flow that's imagined for integrating desktop apps with web services. Making sure that Epiphany can keep logging into Google and doesn't get accidentally thrown into the trash bin as some kind of strange embedded evil hacking in thing. And just working through other issues with core team members, liaising with advisory board members and ecosystem kind of participants, and just trying to keep things working smoothly, facilitating conversations. So there's been a bit of that going on in the background. And the other thing we've kind of tweaked a little bit, I don't know if you could have noticed from kind of financial reports over the past couple of years, we've been spending lots of money. But we have lots of money. So the whole point of actually funding a foundation is that you expect it to do something. We kind of noticed in the finance committee that there was this strange circularity that basically the more stuff that we were doing, i.e. the larger kind of team that we had, more staff, and the more money we were spending, then the more of our bank balance was basically trapped as reserves that we weren't able to spend. So, if we're spending 700,000 a year, we have 1 million in the bank. 700,000 of that needs to be kept in reserves because we're spending 700,000 a year. So we can only spend 300,000 the following year, which I thought was a little bit daft because it basically means like if we spend our money, we have to stop spending our money. So we've kind of decoupled the reserves policy a little bit. So we've kind of defined this idea of like core activity. And that's things like arranging events and running the infrastructure and just keeping all the pumps running and keeping the foundation there as that kind of steward within the community. And our reserves policy essentially guarantees that the foundation has the funding to keep doing that. And then we kind of define some of the other things the foundation is doing as sort of programmatic activity. So there's one initiative over here. We're doing this with we're doing this with engagement, and so those are things that we don't have to keep in reserve. We can use the money and spend it on those things. So maybe a little bit of kind of financial dancing around, but hopefully it kind of underlines the point. If you give money to the GNOME Foundation, we can spend it on doing stuff. Probably the idea behind that. So last thoughts for me on the next slide. Just what are we doing over the coming year within the board? I think the main thing that I'm going to jump into, kind of after GUADEC, is to kind of kick off the search for the new executive director. As you know, earlier in the year, we kind of announced together, Neil and I, that he would be moving on from the foundation. We would be starting a search for a new ED. That's been a little bit slow. I'm sorry, partly my fault. But we're going to sort of get that moving and try and find somebody that brings that kind of non-profit experience and helps us to kind of move to the execution phase on some of these initiatives and the funding that we need to actually start those in the community. Ultimately, what we're here to do is to try and boost the adoption and the awareness of GNOME and the wider kind of free and open source desktop. And so we're just looking for those initiatives to start because they fit into this kind of theoretical model that we have. If we do these things, we can bring more people to GNOME as users, more people to GNOME as contributors, and more people to the GNOME Foundation as financial supporters. So that is our sort of top priority this year, is to just deliver on that. So that will involve the foundation contributing into the project. And sort of participating within that kind of GNOME community ecosystem. That will also involve the foundation kind of going out into different circles and looking for ways to advocate for GNOME and free software in the wider world. So that's everything that we're trying to do this year. And now I will hand over to Cloud Tybalt, who will talk to us about some of the detail of that.
Hello, can you hear me okay? Loud and clear.
Yes, and you don't even sound like a robot today, so that's fantastic.
Oh, wonderful. Let me show you my beautiful face as well. Here I am. Okay, so at some point you might be hearing baby sounds. This is perfectly normal. This is mine. Don't call the police. It's the end of the afternoon here. Okay, so we plan to do things. I cannot turn down my microphone volume. It's just the headset. I'm sorry. But I can try to speak more quietly, maybe. We plan to do things indeed, and not just things for the sake of it, but because they make sense, which is why we have set up a strategy. So let me walk you through our plans. Our high-level goals are the same as last year. We are still a public charity with a purpose to make computers and personal devices less evil, and not just for people who were lucky enough or cursed enough to have an education about it. That's a high-level vision, and it doesn't say much about how to do it. We said last year that we want to build technology people can trust through a diverse and sustainable free software personal computing ecosystem. But how can we do it when we're competing with companies with more capital than some states? The foundation doesn't sell product or services, neither to individuals nor companies. GNOME is free and we don't sell support. The foundation can only earn money with targeted, planned, and transparent programs funded by donations. Because of the very open nature of the GNOME project, the foundation can't decide for one direction for the GNOME project for everyone. To have some weight, the foundation needs to be a significant contributor to GNOME. It needs to work with the people who make GNOME and take the existing culture into account to ensure the project will benefit everyone. Individuals have been a good support to the GNOME Foundation, but most of their contributions are in the form of design and code to the GNOME project. Organizations have more financial power than individuals. It's easier to get a handful of organizations to agree on funding a specific program than to convince thousands of individuals to get the same budget. The more organizations are willing to support a given program, the more ambitious, successful, and sustainable the program can be. So our role has been to shape programs that are in the interest of the GNOME project and community, making the GNOME project more appealing for people who don't already use it, and programs that are appealing for organizations willing to fund them. Mandatory XKCD to compete with very wealthy actors, relying on the free time and goodwill of individuals is not realistic. We need to provide a place, or dare I say, a platform, where people can sustainably contribute to the project. As you can see, graphic design is my passion. We decided to go with 3 major initiatives, each of them having an impact at a different stage of the contributor journey. Our community is already active and hard at work to make onboarding for newcomers as easy as possible. The foundation wants to increase its involvement, be it by updating the documentations or having more people around to guide newcomers and answer to tricky questions. So the double objective here is to make it easier for people to learn valuable skills that can help them making revenue with it, and to funnel more contributors to GNOME. The second initiative is to make it easy to build apps answering today's challenges. We're moving towards a model where every computer in the world is not much more than a terminal connected to the cloud mainframe. This has a significant impact on us as individuals, but also as a society. We are increasingly losing control over our data and apps. And I recommend yesterday's talk by Rob about that to learn more about it. Despite the recent trends of getting everything to run in a browser, GNOME has kept its culture of polished native apps. This makes a perfect candidate to explore a radical shift in how we build apps, with data on the user's computer first, and ideally without any server to synchronize data between devices. The foundation wants to provide the building blocks for app developers to be able to build local-first apps without hassle. Finally, once people have learned how to create an app and have all the building blocks to make it happen, we need to provide them the means to stick around and keep doing great work. This means it should be easy to distribute apps and earn an income from it. From the user side of things, you shouldn't go through a maze to support the creator of your favorite app. This is why the foundation is already working on adding payment support on FlatHub. I'm excited about those initiatives because they bring the systemic changes to make GNOME an appealing platform for everyone. They are meant to extend the work our community has already been doing. The GNOME Foundation indeed has the privilege to be able to build on top of the fantastic work of a vibrant community. We need to acknowledge in our community the work that has been done to bring systemic changes to GNOME. One of the major projects of the past few years has been LibreWaiter, the library built on top of GTK to provide ready-to-use UI building blocks to everyone who wants to develop an app for GNOME. It has been key for the GNOME community to develop apps that implement the human interface guidelines of GNOME without too much hassle. On the design side, we need to credit Tobias Bernard and Sam Hewitt on behalf of Purism, but also Alan Day and Jakob Steiner on behalf of Red Hat. The following contributors worked on LibreWaiter both with their Purism hat on and as individuals on their free time as well. Alexander Mikhailenko, Adrien Geplaza, Julian Sparber. The following contributors worked on LibreWaiter as individual contributors on their free time. Manuel Genoves, Nahuel Gomez Castro, Maximiliano Sandoval, Christopher Davis, Felix Hecker, Xander Brown, and Yeti Zone. So a big thank you for providing the building blocks to make fantastic apps. It's great to have building blocks, but it's even better to know how to use them. Documentations can sometimes be overwhelming for newcomers. Emmanuel Ebassi did a complete overhaul of the GTK documentation. And on top of that, Julian Hofer has done an incredible job at writing a book for complete newcomers so they can write GNOME app in Rust. Bilal El Moussaoui, Sebastian Dröge, also known as Slomo, Ivan Maladiecki, also known as Yalta, reviewed it. Thank you all for making apps creation less scary. LibreWaiter and the GTK RS book can allow people to create reasonably good apps quickly. Maintainers can ask to promote their apps in the GNOME Circle to give them more visibility and join a curated list of high-quality apps. More experienced developers and designers can share their expertise to make said apps reach the excellence level required to join GNOME Circle. A huge shout out to members of the Circle committee who spent countless hours reviewing apps and helping maintainers to make them better. Sophie Herold and Tobias Bernard in particular have been truly heroic in doing so. So a big thank you to you both. But Sophie did not stop here. We used to have an apps section on the GNOME Wiki, which was badly outdated. Sophie has created almost single-handedly Apps for GNOME, an engine that fetches information in the Git repository of the various applications developed for GNOME and displays them on a gorgeous website. As long as maintainers keep their project metadata up to date, which they need to do anyway, Apps for GNOME is going to be updated as well. This was a long-standing issue, and Sophie found a way to automate things, making it much more robust than hand-edited wiki pages. So here again, huge thanks to Sophie for building such a polished and useful website. Having up-to-date information on apps is good, but sometimes people want to know what's happening inside the GNOME project between releases. Felix Hecker developed a bot everybody can talk to report what progress they made over the last few weeks. On Friday evenings, Felix asks the bot to produce a digest of it, and everyone can have a good idea of what happened this week in GNOME by browsing thisweek.gnome.org. While it can sound trivial at first, this shows to the outer world how vibrant the community is, and it allows us to speak with our own voice. Many thanks to Felix for both writing the bot and setting up the website, and a sincere thank you to everybody who contributes to the great reports. I picked some examples of projects which are outreach-oriented, but this is not an exhaustive list. I could have talked about Builder as well, which provides an easy and straightforward environment to create apps. I could have talked about Flatpak, which is foundational for much of what we are seeing here. I could have talked about Shell maintainers implementing an easy-to-use desktop environment for everyone, or even about the very experimental work to make Shell run on phones, and so much more. There is already so much time for shoutouts, so my sincere apologies if I didn't shed more light on your project. Every contribution matters. Keep up the good work. You are the one making GNOME great. And now over to Neil to have a look at our finances. Thank you.
over moving from a vertical to a horizontal workspace. Actually, what seems to have happened is that when people used it, they went, oh, this is literally fine. It's all okay. People very quickly adapted, and there was very little concern over that. Everyone seemed to like it. And there's been some, this really has been seen and received a lot of feedback, as it's very much a polishing, and it is really a fantastically, a really coming together of the GNOME 40 release to create something that's really quite special. And there's some of these items in here seem really simple and can only be explained in a couple of words, but the overall effect of it has been to really create a really polished release. So some of that is the dark style preference. So the idea that you can have a universal dark style that goes between all your apps. Or things like just the new screenshot experience, which has been absolutely fantastic and has people really, really useful to use and very intuitive to use. Again, we're seeing continued ports of apps to GTK4 and libOrder has been mentioned, and a couple of new default apps in there, so text editor and console. A very useful one, especially for enterprise customers or those who, like me, unfortunately have to occasionally support our parents when they have issues with their desktop, is remote server connections with RDP support. So I can actually go and connect to my parents' desktop to find what they've messed up now or something like that, and maybe goes, oh, you've deleted all your apps from your from the dash. Great, I don't know how you did that. Oh, you've moved them all into one folder and then given it a space for a name. Fantastic. I don't know how you did it, but fine. Okay, so we're able to fix that remotely, which is better than a 6-hour drive to go and see them. And of course, performance improvements. This happens every single time, and I think is a fantastic way. I think in the State of the Shell talk, they'll talk a little bit more about this. A lot of the stuff that actually happens is not necessarily registered as performance, because it is still the sort of things that happen just to make things more efficient and improve them anyway. And out of that, you get a lot of performance improvements. So we also, apart from GNOME 42, we had PWAs. This is progressive web apps. It's progressive, yeah, let's go for progressive web apps. This has been one of the programs that we've been running over the last year, has been to integrate progressive web apps in GNOME. Initial work is from Phaedrus, and who's waving at the back there for people in the room. Thank you very much for that. So this was added support to GNOME software and for web apps with basically GNOME Web, and also quite a bit of work on libportal to make this work. And the idea here is there is a lot of progressive web apps out there. There's a lot of websites and apps that people want to use. We absolutely recognize that native apps are something that is a better experience. You don't have to have necessarily an internet connection to use it. It remains all free software. People can use things locally. However, there is still a desire from people to actually use the things they want to use. If you are required by your job to use Office 365 or Outlook or something, then you have to do that, and you don't really get a choice in some cases. So this is the ability to use not only proprietary apps, but there's a lot of free software, progressive web apps out there, and to have those a lot more integrated into the system, so you're able to use those in a lot more native way. Future work, there's some possibilities for Chromium upstream and other desktop launchers. We're also talking to distributions at the moment about the ability for GNOME or distributions themselves to produce a list of recommended web apps which could appear in GNOME software. So it'd have your standard software, and there could be another section saying other software from the web. Obviously, that needs a level of curation. So we're talking to distributions about if they'd be happy including that, or the sort of ways of introducing those. So another project that we've been running over the last year is for FlatHub updates. So we've also been working quite a lot on FlatHub, making sure that this continues. A lot of the work that we've been talking about is around the ability to accept payments on FlatHub. We're getting very close to that now. But part of that work is to make sure we're able to verify who uploaders are. As people may have seen over the past 2-3 weeks or so, Microsoft Store have had to adjust some of their policies in lights of free and open source software on there. Essentially, the issue is there was nothing really in their policies to stop 20 copies of GIMP being uploaded by random people and then trying to charge for them. So what we wanted to make sure is before people were able to accept donations or charge for their software, then there would be a level of this is the person who actually controls the application. So for example, we didn't want org.doggysite.totallyreal.spotify to be able to upload and say, hey, yeah, this is totally a Spotify client. So you would have to verify either by DNS or well-known or something that you own like com.spotify or something to be able to upload within that app ID. And then beyond that, we had a concept of allowing donations or even requiring payments. And a lot of work has been done with there, thanks to CodeThink and James Westman, who we contracted both of those to be able to do this work. And as an example here, so the bottom photo which we have over here, which Theobald, for the sake of the screen, is going to draw a nice thing with his cursor. Perfect. This is really interesting. So what this shows is, can't quite see it that well, but this would be the application developer's view of their individual applications. And here are some little sliders. Now, the idea there is that a percentage would go to FlatHub because we're processing the payments. And unfortunately, as we discovered in the World Financial or everywhere else, nothing is free. So we need to pay bank fees, and we need to actually like run the platform and pay people's salary for doing things like application reviews. So there will be amount there. But then there is also a percentage slider that could go towards, that the application author could pick, which would go towards the platform. So this would either go to free desktop or to the KDE runtimes or to the GNOME runtimes for providing that platform and being able to support that. Again, people can choose, say, actually, I just don't really care about any money for myself. I want it to all go towards my platforms, or they do want to collect some. And so there is a system in place there. We're able to do that. We also imagine that from a user's point of view, there will be a couple of different options for people to be able to either donate either more than minimum amount, or we'll be able to have potentially some items which will be a pay what you want type scheme as well. So we're trying to keep it quite flexible for people. Now, on the back of that as well, another couple of things that we wanted to integrate with that is two concepts. So one was repository filtering. So if we wanted to be able to have the concept of only verified apps, then that would be able to be a view you have, or even just have only free and open source software apps. So we've introduced concept of repository filtering. That's particularly useful for some distributions who don't want to expose any of their users to anything proprietary, or even to promote free and open source software beyond and further than proprietary apps. The final piece of work which has come over the back of this, partially because we have now a developer login area, so people can log in and manage their apps, is the concept of direct binary uploads. So before this happened, essentially you put a pull request in on GitHub, the FlatHub builders built all the applications using the manifest, and then we uploaded direct to FlatHub. That's fantastic, except for some larger applications. So for example, with Firefox nightly, we don't really want to be building Firefox every night when Mozilla literally build Firefox every night. So we don't want to take that and then just rebuild it ourselves. So this is the ability for example, within the Firefox CI system, to them, they have a secret token which they could, once they've built it, then publish that binary directly onto FlatHub itself. And part of the way we'll be able to do this is to have this backend so people can manage their own secrets and their own keys. Previously it's been email Bart, and then after a year, when you've forgotten and your key expires and then everything starts failing again, then email Bart again, and then find out he's on holiday, and then you email me, and I have to like email Rob probably, and then try and work out what's going on. And then some of Rob's children are ill, and it's fantastic. So this is a way within the back end of actually people being able to be able to manage that themselves. So the third main one which I want to talk about, programs that we've got going on is, what am I talking about? GTK4 support, excellent. I can talk about that as well. Yeah, we have GTK4 support. As mentioned by Thibault, one of the really interesting things that we've seen is the release of GTK4. So we had GTK3 for a while, and as I'm sure most people here are aware, GTK 3.0 was a bit of a different beast from GTK 3.10 or 3.34 or various other things. So what we finally got out the way is GTK4. There's stability promise, people can use it, people can rely on it. We're not going to break it. New features will have to go into GTK5 instead. And we've seen that's also the release GTK4 allowed us to really deprecate some of the old legacy ways of doing things. So making things more efficient, making things easy to use, and quite frankly, enabling some of the features and some of the really nice bits of application development that we just weren't able to do before. Now, for people to actually use it, they need a few things. So things like developer documentation, things like developer advocacy, and actually showing people how they're able to build apps and build things using GTK. So we contracted Emmanuel again to sort of improve that developer experience and the ease of use of GTK, and also to identify any missing functionality. So what we saw over the quite a long time of using GTK3, for example, is applications would have to re-implement certain widgets or certain systems, and they would all do them themselves because there wasn't a widget within GTK itself that they could do. So it could be something using particular types of list views or something like that. And so part of the work here was to go and re-implement that and identify if there's any sort of missing pieces. So that's not only looking at GTK, but also looking at things like Qt, it's looking at Flutter, it's looking at the various Apple systems and things like that, and Java as well, to identify, okay, so within these UX systems, they produce these sorts of widgets, and where do we line up, and how much and which applications actually need to use these. And then, of course, advertising this and showing what we do and writing documentation and giving tutorials about how we do. So as some people saw from some of the talks yesterday, we now have quite a few GNOME streamers. Emmanuel has been doing this regularly every Wednesday, I want to say, at 4 p.m. UK time. And so we've been streaming live on Twitch and then putting those videos on YouTube, actually showing people how to create apps and how to make things. Emmanuel has found this particularly interesting because he's been a toolkit developer for mumble years, but he actually wrote an application called Amberol, which is a very simple music player. And this was an example of, here's how he can write an application really easily, and here's the sort of best practice to do it. And he actually ended up really enjoying it. And that definitely comes across in his streams and some of the things he does. Okay, let's have a look at the next slide. Some events. So despite there being a pandemic, there was still a number of events we went to and attended, admittedly, virtually for a lot of these. So we continue to attend events. Few ones, of course, we have GUADEC and GNOME Asia. The Linux App Summit was a interesting one because that was, I think, one of the first ones that started happening in person again. So that was in Rovatero, and it was fantastic to see not only loads of GNOME people, but loads of KDE people and loads of people from throughout the ecosystem there. There's some others we've attended, like FOSDEM and Seagull, the Open Source Summit India. Interestingly, both myself and Rob were also at COP26 in Glasgow. there was a day where we were talking about the importance of open source software for sustainability and how this is becoming quite essential in how we produce software, and it has a real impact on climate change. I have also been talking with KDE quite a lot to look at KDE Eco, and so we're looking at things like certification for GNOME software and how we can ensure that it receives actually certification for actually being sustainable software and helping reduce the impact of computing in a couple of ways. Firstly, that because it's open source, that has some inherent advantages, that it doesn't require 12 groups of people to re-implement the same stuff and all the computing that has to then just create that. But also, there's been some interesting studies done against, for example, in Germany, against 2 unnamed office suites. One of them didn't use a lot of energy and another used about 12 times the amount. I won't name which ones those are. That is left as an exercise for the reader, but it was shown that open source office suites use a lot less energy than market-leading alternatives. Still go for that. So yeah, there is a real advantage there that we can push with open source software, and it's becoming a recognized issue. So if you have a look at our next slide, please, Diebold. Strategic initiatives. Okay, so here's a bit more detail about what we were talking about before. I think I have I'm not sure if Theobald can sort of follow along with I have a little laser pointer. Hopefully Theobald can follow along a little bit with his laser pointer for the stream. This could be interesting. Okay, so we have a few different areas that we're kind of looking at here. We're kind of putting this into 3 sort of areas, as mentioned before. So probably the first one to talk about, which is the sort of base layer, which Theobald was talking about, was around attracting and keeping newcomers. GNOME has always been known and is quite famous for being very attractive for newcomers. We have a newcomer system, we run newcomers workshop, we're very encouraging, we invite people into our community. We do some of this by being that welcome community, but also educating people, supporting them throughout their journey, and then trying to sort of introduce people. That has value within open source, with not only open source communities, but with major employers. So within some of our corporate backers. What we often see is people come along and they do stuff with GNOME, and then on the back of that, they're able to find paid work. And there's going to be a panel tomorrow with Melissa? Tomorrow at 11 with Melissa around how contributing to GNOME has helped people's career. And so we thought, so perhaps what we could actually do is do something bigger with this. So this is the idea around this newcomers and corporate backers section over here. We have Google Summer of Code, and we have Outreachy, and these are fantastic programs, and long may they continue. But we've identified an opportunity, or what we believe is an opportunity, for a slightly different type of project. So the idea here is to get a group of people who are fairly new to open source software community, not necessarily programming themselves. So this is not a let's teach people to program, but is a let's work out with people how to contribute and contribute to open source software. And if we have a number of those, then they can work in a team. So rather than having a single person working on a small project for a few months and then going away, this would be a few more people working for a slightly longer period of time and in a group of people to create a larger impact. That would then work with a group of mentors as well to be able to sort of teach them not only how to do things like write software and do pull requests, but potentially how to work together as a software development team as well. So concept potentially like sprints, or being able to work out priorities or backlogs and things like that, which is important to employers. And then the idea is that we can receive sponsorship for this, because this is a very useful training and organization, almost even apprenticeship program. And then we'd be able to provide proper funding, but both for those apprenticeships and those people coming into the schemes, but also for our mentors. Because the amount of time I know it takes that to do a proper mentorship job is not really compensated in a way that is actually sustainable. It keeps on falling over the same 2 or 3 people all the time. And so being able to actually properly compensate our mentors for the amount of time they put in could produce a really interesting program around there. So this is one of the themes that we're trying to do, is trying to actually make sustainable contributions and introducing people in a sustainable way into open source software and within GNOME. A second one, which we've talked quite a little bit about, is around the App Store, which is around being able to, for people to be able to charge or receive donations for this. There's a couple of reasons why we believe this is important. Firstly, there's long been this concept within open source software. I've been involved with free and open source software for 20 mumble years or so now. And please forgive me, Free Software Foundation, but the use of the word free is not useful here. The concept that that somehow it is all free, and it's free as in gratis, is something that has pervaded throughout all open source software communities I know for many years. The concept somehow that money taints the amount of the pureness of what we produce. I'd say the lack of money taints the pureness in what we do, because if we are saying that anyone can contribute, all you need to do is show us the code, that's fantastic, as long as you're rich and privileged enough to be able to have a computer and an internet connection and the spare time to be able to learn to program and get involved in communities and, say, go to conferences all over the world and perhaps, lucky enough, not have to deal with children and childcare, or even just to have a proper job in order to be able to do this in your spare time. So as we look around our open source software communities, I would ask certainly everyone on the stream and everyone here to consider the makeup of our communities and wonder why it looks like it's people who've been able to use their spare time to join in these communities. One of those barriers to entry is the ability for people to earn money from things they do, to have a return. We had a talk in Thessaloniki from a couple of GNOME contributors from Africa, and their comments was like, okay, so I can go and learn I can take time out, I can stop my day job, I can go and learn to program for 3 months, and then how do I feed my family in Linux? It's like, you could get hired by Red Hat? Well, maybe if you're one in the 1,000 or so who get to do that and you've been contributing for 10 years or so. But so what happens is like, well, we'll make an Android app because we can sell it and that produces money. So the idea here is to try and make it more sustainable for people to actually join in our open source software ecosystem, and to be able to do that and removing the barrier of, well, you have to do it entirely as volunteer and you're never going to get any money from it. And so it's trying to produce something around that. The final one here is around decentralized apps and features. I'm wondering if I can pass that over to Theobald a little bit to talk more about that as he's been driving this. But as mentioned, this is the concept that relying on a stable internet connection, on being able to ensure that all your data is sent to a central place, is something that is becoming increasingly unreliable. So it's maybe accepted as something that is possible within, say, central US or within the UK or within Europe, but there's some places in Europe, like in the Ukraine, for example, that your internet connection might suddenly go away, or you may not be able to talk to your central services. So how do you retain that? How are you still, in that world we all imagine, which we're empowered by technology we can trust, how do we ensure that people are still able to access the computing and still be able to work with each other? And we think that this is a very useful piece that we're able to do, and that we're able to introduce concepts such as peer-to-peer distribution of software and also their data, and ensuring that things exist on your own device, both as a way to ensure that not only is it just for within hostile regimes, but just for within people's own data, or even within Western countries, because having data on your own device then also reduces your potential climate impact as well, by not having to rely on servers. If you're running your own device anyway, then making sure that your data is there as well and you're able to share it locally without having to go through various hops to the internet is also a good thing that we can try and look at. So there are three main areas that we are going to continue to look at, and the programs that we're developing over the next year. They're obviously, as mentioned, they're in various different stages. Probably most developed at the moment is concepts around the App Store and what we're trying to do there. Then kind of in development a little bit more, and we're currently actively looking for funding, is around newcomers and corporate backers. And then thirdly, a idea that we have, but we're not quite ready for looking for funding yet, but we're certainly starting to build up a program around that, is around decentralized apps and features. So we can have a look at the next slide once T-Bolt is magically the presenter again. That should be you, Thebe. Q&A. So at this point, we typically take questions from the audience, or either here or online. Any questions that anyone has about the foundation, what we're up to, what my favorite tacos were last night, anything really goes, and we'll do our best to kind of answer you. Okay.
We can just jump in with
How should we do this? Yeah. Just jump in. Go
on. Well, a technical question, probably not a great one for the AGM, but yes, there's an interface that GNOME software uses to talk to GNOME Web to put, pin applications onto the desktop, and so kind of basically install the PWA. Any other web browser can implement that. We actually did have a meeting with the Microsoft Edge team and basically said, could we have an API that would allow us to do this using Edge? They're thinking about it, but that would be cool to have some alternatives in terms of people being able to not use a different browser engine from their normal browser to do the web apps, because then cookies and things would be shared. Can someone make a fork of GIMP and upload it to FlatHub? Yes, the license allows you to do that. You probably can't call it the GIMP, so you'd need to name it something else. And then if people actually find and want to use your version of the GIMP, then you can charge for that. But only developers from the GIMP will be able to verify that they are actually GIMP developers and then claim donations and things for that. So the verification is basically the first step for us to enable any kind of financial features in FlatHub. You have to prove that you can control the domain or the GitHub organization or the GitLab organization on FreeDesktop or KDE or GNOME or GitLab.com. So you have to prove that it's your app before you can turn on the payment controls and that screen that Neil was showing you. Would the payment have any sort of restrictions? No. Basically, we're allowing app developers to set whether they require a payment or whether it's optional, set a minimum amount or recommended amount, and the share that is shared with the platform, so GNOME or KDE or FreeDesktop. If you have a problem with that, you need to take that with app authors. The idea is that we're producing a marketplace, and then people can find kind of what works for them. Will FlatHub support recurring donations and subscriptions? I would really, really love this, because I actually think it's a better model than one-off payments. One-off payments is a kind of very 90s idea of software. I bought my first copy of Red Hat in a box with a CD and a manual. Probably not that useful. It's actually a bit harder with Stripe. It's surprisingly hard to get to the point that we're at with enabling FlatHub transactions. There's a lot of Stripe API stuff, there's sales tax, there's sort of legal incorporation and compliance questions and governance questions and transparency, like where's the money going and how much does this cost you to provide and all these things. So we're working through a lot of stuff. So sorry if it looks like we're being slow or not doing anything. We're actually working quite hard on it. the transaction stuff is in the last phase now of basically adding support for Stripe's million transaction tax codes. So, if it's a productivity app or a commercial application or a game or something, because these are taxed differently in different states and different countries. So Stripe needs to know what the app is so that we can collect the right taxes and do all that for the app uploader so that it's not a massive pain in the rear. But we are hoping to come back to it and add the subscriptions and recurring donations. In-app payments. Oh man. Yeah, Q5, 2025. It's not on the roadmap currently, but obviously it would be great to do it. It becomes, so the Flathead backend exports an API, basically, that the web app is talking to the kind of backend. And if you're authenticated, you can use that backend. So we could add API calls there that, for example, GNOME Software or KT Discover could do transactions, and potentially the app itself can also log in to FlatHub and look at your transactional payment status. I'd probably prefer to see you either buy like an add-on that then shows you've paid $5 for that thing, or it checks, for example, whether you've paid at all or whether you've got a subscription or donation to that application. Are you a sort of paying supporter in some way? So I think those things are probably easier to shoot for rather than actually kicking off a whole transaction flow from inside an application. I'm going to stop talking. Neil, your turn.
Sure. So comments, I agree. Increasing gratis isn't helping for floss. How do we address income inequality problems so that anyone can afford it? Can we prioritize indexing app prices on regional income/prices? So this is very similar in the way that Steam does it for games. In theory, yes, because Stripe will be able to support multiple currencies and multiple price points. In practice, please bear with us. At the moment, as Rob mentioned, we are talking to a lot of accountants and a lot of lawyers. There's some interesting tax questions. For example, what happens if someone in France buys a Australian app author's app and then that gets interfaced via whatever we're doing in the US? How much VAT do you pay? Is there sales tax involved? Where does that go? And so at the moment, we're looking at launching in a quite a restricted set of places. So certainly the US, hopefully more than one state in the US, that would be useful. Beyond that, hopefully probably the EU and the UK. And then we're hoping to roll out as quickly as we can to other jurisdictions as well. So yeah, it's something we're considering. It is a problem, mostly a logistical one that we're kind of having to look at. Favorite tacos? Oh, I don't know, anything involving nice beef or pork or something with some nice spices on. That's certainly my favorite. Certainly one thing it's that I've missed from being in Mexico. I think I was last here about 5 years ago with Manuel, who's the local organizer in Zacatecas, and we've been trying to get back here for about 5 years or so, and not just to the large amount of mezcal he keeps feeding me as well. Rob, what's the Foundation's progress on climate goals, and what's the GNOME projects on its Primus goals, and how can the Foundation help with that? Have you been looking at this? No.
This question's a plant. Philip is the one who's been assessing the Foundation's and the project's climate impact.
Yes. So for this, whoever asked that question, Mr. Philip W., I'd suggest you talk with Philip Withnell, who's been doing a lot of work on this. Again, so it's looking at things like KDE Eco, so we've had some calls with them on how we can reduce our impact. Again, this has been kind of useful as well, so showing the ability to have remote participants within GUADEC has certainly been useful.
Yes, I mean, I think it's a legitimate question. We should probably look at, adding it to the board's consideration and making sure that we're kind of keeping track on the climate impact, particularly, obviously, the compute that the Foundation pays for is one climate factor factor. Travel is another one. So just looking at sort of policies and ways to measure and manage climate impact of our activities. So yes, flippant answer aside, it's probably something we should put back on the agenda for the board because it's been a couple.
Okay, I'm getting signs from over here that we need to start wrapping up, so I'll very quickly say, Niels, yes, we're going to be doing periodic audits. When things change names or like main descriptions or something, they'll go through a re-audit queue. Emanuele, how do we improve the ability for non-advisory board people to work on the platform and receive funding for their work? So partly, some of this could be from, again, that cut towards those platforms, which we talked about. So when application authors say, okay, some of this can go towards the GNOME runtime or the KD runtime, then some of that funding can help fund those actual underlying pieces, which are kind of important. I also have an action to go and talk to CII about some of the GNOME platforms and the GNOME libraries, because they are actually quite important infrastructure these days. If you have a look at glib, for example, the amount of stuff that depends on that, it's like everything in the world. So actually having the ability to get funding for that, to support people who like support things like glib and those underlying libraries, I think is important. Still running out of time, so if we can quickly go on to the next couple of slides. Some sad news over the last year. We lost a couple of our core contributors. We had Maria and Anders, who I just wanted to remember the amount of work that they've done for us over the 4 years. Maria's contributions were certainly way beyond GNOME. She was certainly one of the founding people who created the outreach program for women and Outreachy, which has been a huge success. And Anders, I believe, found an old presentation from him in GUADEC 2004, I think, which is about libgnome or libgnome UI. So actually creating the very first bits and the building blocks of GNOME. So I just want to recognize that over the last year we have lost Maria and Anders, and to thank them for all the work that they have done. On slightly nicer news, I guess, I'll hand over to Rob again.
Unless any other board member wants to volunteer, but this is the last bit. I'm sure most community members know, but we have an annual award, which is literally a pair of trousers that was found in Seville in 2003 or something, but donde este mis pantalones, we found them again. We have a ceremonial or pair of pants to award to a community contributor who has really gone above and beyond. And we tend to kind of mix it up between some of these kind of long-standing and kind of very old contributors to GNOME that have been around for a long time, and we kind of recognize just that kind of length of service, and length of service, make it sound like a kind of a work medal. No, just the amazing contributions over the time. And we also tend to look for, you know, rising stars and newcomers that have really made a huge impact within a very short time in the project. A bit of a guessing game. So the board has decided, you know, we've gone out for nominations, and we found, you know, one community member that the board was really happy to recognize and appreciate their work. So this person has a passion for espresso, and they are comfortable with sharp tools for woodworking. They care deeply about the public face of GNOME. They've helped maintainers to make fantastic apps with very detailed reviews. And they've fought for the rehabilitation of a very small mammal, not to be confused with any kind of Pokemon. And would certainly never lose their data if they had a problem with their computer. And so if you've not guessed by now, the Foundation is extremely pleased to award this year's appreciation pants of thanks to Sophie Herold. The amount that Sophie has achieved in the past couple of years since joining the Foundation as a Summer of Code student, and just the amazing kind of consistency and imagination and dedication towards GNOME Circle, building the apps website, building a beautiful backup application that's been a problem in GNOME for 25 years. Just fantastic. So I strongly support this award. So thank you so much to Sophie. I don't know if she's here and wants to say something. We normally try to do all this in person, but we are, in 2 places and around the world. So this is a bit of a out to the void. But thank you very much, Sophie, and we will contact you later regarding pants or equivalent.
Okay, I think that's it. So thank you very much for everyone for coming along to our AGM. Again, if anyone has any more questions, you can find me or Rob or various other people around, and I'll just hand over to Christy now. Thank you very much, everyone.
Don't leave. Only 1 minute, just a quick group photo, since we are more people now and we can have it. It's only 1 minute, so please run here on the stage until the next presentation starts. Run, 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 run. Yes, yes, you can go. So in the main track, the next presentation will be from Felipe. Using GNOME boxes to contribute to GNOME. Felipe? So let's wait until Felipe comes. Yeah, here he is. No problem.
Thank you. Sorry for the time to go. Right, so this presentation is a little bit introduction to GNOME Boxes, which is this virtual machine application manager that I developed. And the idea is just to show you how GNOME Boxes can help you contribute to GNOME and beyond just the other use cases that Box traditional has. For a long time, I feel that we have, actually I can take my mask off. We have focused boxes on contributors who want to be able to run Windows workloads. So example I always use in my talks is that my mom needs to file her taxes on Windows. So she runs Fedora as a distribution and has a Windows virtual machine. Sorry, I was running. And she has a Windows virtual machine. Another use case of boxes is for people who develop distributions and need to be able to test multiple versions, right? So my idea today is to show how you as a GNOME contributor or as a distro packager can actually use boxes to make your contributions much easier. My name is Felipe Borges, by the way. I work for Red Hat. I've been contributing to GNOME for about 10 years. And I maintain GNOME boxes, and I'm also an outgoing board member. So one of the features that I like the most about boxes is the easy downloads. We have a database of operating systems that we support, and we have a list of URLs of freely available operating systems that you can obtain from the internet. So if you're using boxes, you can just create a virtual machine by just clicking on the new virtual machine button and selecting the operating system you want. Boxes will download that operating system and pre-set up it for you. This is only possible because this library, which is called libOS-info, detects images of operating systems and also has a database of which virtual devices are the best for that virtual machine. So for instance, if you want to create a virtual machine, you don't know much about virtualization, you don't know much about which operating system support certain devices, which system resources each operating system needs. So for instance, Fedora needs at minimum 4 GB of RAM to run, or certain distribution needs a certain type of video driver for running virtualized. So this database provides all this data, and you as an average user who just wants to virtualize, you don't actually need to bother about getting to know virtualization. Yes, another feature that I like is express installations. So as a developer, I end up installing a lot of virtual machines every day. I work at Red Hat, and therefore I maintain various versions of Red Hat, my packages in various versions of Red Hat Enterprise Linux. Same thing about Fedora, and I imagine that people who work on other distributions do the same. So it's kind of tiring that every day you need to like start a new virtual machine from the scratch to have like a very brand new operating system. So with Express installations, we support a few operating systems which we can do a scripted installation. You just enter your username and your password, and boxes will just perform automatic installation and create a virtual machine for you. So this is very convenient. You can just go grab a coffee, and when you come back, there'll be a notification saying that your virtual machine is ready to be used. Yeah, another feature that is very convenient for this type of workflow is sharing files with a virtual machine. So if you are using Nautilus, the GNOME file manager, you can just select a file and drag it into the virtual machine window, and that will transfer that file into the virtual machine. So this is very convenient for sharing files. We also support shared folders. So you can set up a shared folder on your host machine, and that folder makes itself available inside the virtualized operating system. This is like a jargon of virtualization to call the host operating system the machine the system you're running on your bare metal, and guest the virtual machine that's being the operating system that is being virtualized. Yeah, there we go. So here's a simple example, right? I use the Red Hat building packaging tools to produce RPMs. Imagine that folks developing for Debian, for Ubuntu, they are also producing their deb files, and you want to be able to test those against your target environment. And a lot of times this is not gonna be what you're running on your stable developing machine. So what I do is that I build my RPMs on my host operating system, and then I just drag them into, let's say, a Red Hat Enterprise Linux 8.7, so I can install those RPMs from there. This also could be done, for instance, for Flatpaks. So if you're using a GNOME Builder, you could easily export your application as a Flatpak bundle and then just drop that bundle into the virtual machine. Of course, runtimes with Flatpak are also targeting multiple versions, so you can actually do this on your host operating system, but sometimes you want to test things like at the integration level. You want to test how your application talks to system components. So having virtual machines is much more convenient for that, because sometimes you just don't want to change the system components of your host operating system to something that is bleeding edge that might just mess up your existing installation. So another use case that I find it to be very convenient for developing distributions with boxes is testing upgrades. In Fedora, we do this Fedora upgrade test day, where you can test the upgrade from Fedora 35 to 36. And this is another thing that all the other distributions which are not rolling release probably have the same use case. You want to be able to test whether the path the user is going to have from going from the existing version to the next version is going to function. And you probably just don't want to test it there just once. You want to test it in various scenarios, various contexts. So one convenient thing that Boxes allows me to do is use snapshots. Snapshots are like a state of that virtual machine in a period of time. So one thing that I usually do is that I create a snapshot of my existing virtual machine on a Fedora 35 version, and then I execute the upgrade to 36 and compare the results to see if it succeeded, and then I can easily click on the revert button and get back to Fedora 35, so I can undo my changes. So this is very convenient for doing destructive things on your operating system and be able to revert to a previous state where things are fine. You can create multiple snapshots and be reverting between them. Snapshots can be also like offline of the virtual machine, but you can also be live snapshots. So you can also really see the changes happening in front of you. Yeah, there are various ways to contribute to GNOME. I have been so far specifically talking about programming and building packages, but contributing to GNOME goes way beyond that. A lot of people are involved in translation, marketing, all those things like organizing events, but writing release notes, for one, it's something that is usually inconvenient for a lot of people because they would need to build a new version of GNOME that is still bleeding edge and run it against their host operating system again. And this sometimes gets contaminated by some artifacts. For instance, some distributions apply certain theming, some distributions might have certain fonts that might differ, some users might have some accessibility needs that differ. So being able to test things as they are the default on GNOME is also pretty convenient. So the release team in GNOME produces automatically this GNOME nightly image that comes from the GNOME continuous integration and produces a bootable image of GNOME, and that can be easily obtained directly in Boxes. So this way, you can just test the latest GNOME possible in a virtual machine, and it's very convenient for release notes writers to just boot up this virtual machine and take screenshots, or for somebody who is just studying what is implemented in another operating system to just try that out. Yeah, another thing is GNOME Shell extension developers, right? If you develop an extension, you are usually supporting the current version of GNOME, but there's a new version of GNOME upcoming, and you want to make sure that your extension is still working. A lot of times, the GNOME Shell changes and your extension breaks because there's not a stable or a defined API for GNOME Shell development, so you actually need to tap into the existing implementation of GNOME Shell. So extensions, they eventually break from one version to another. So being able to also test the latest GNOME Shell on GNOME OS against your extension is also a way for you to predict the changes in GNOME Shell and push your extension changes way before the final stable release of GNOME comes out. So frequently I see that once GNOME has a stable release, there is still a period of a month or two where extensions are catching up because people are finally receiving those updates throughout the operating system path. Like their distributions are packaging GNOME Shell and delivering to them as updates. So I feel the testing against GNOME OS is also pretty convenient, and you can just, as the example before, you can just drag the extension file inside the Boxes window, and this way you would be able to test it against the latest unstable GNOME Shell. Yeah, another thing is that distributions, they apply their own modifications. That's the whole point of a definition of a distribution. And as an application developer, a responsible application developer, I expect that you'll be trying out your application against different distributions to see just how it behaves, to see if there are some inconsistencies, if there is some specific user styling that doesn't work well with a different contrast in a different theming or something like this. So that's another use case. I work in Fedora, and I test usually against Fedora in my host operating system, but I also test my applications in Ubuntu and other distributions just to see how things feels like. One can tell, for instance, that this is the old LTS of Ubuntu, but you can tell that the window decoration is different, that the theming is different. So it's important for you to actually understand how your users are going to consume your application. So I feel that that's also a pretty convenient thing to do. Yeah, And lastly, I want to actually discuss a little bit about some future ideas that I'm developing. One very interesting one is that I want to add to Boxes this possibility of managing its virtual devices. So far, Boxes will just choose the virtual devices for you, and you kind of have to like go along with it. And the idea now is that you'll be able to even create some sort of fake virtual devices to be able to test different hardware pieces that you might not have. So for one, it's very common that you try a virtual machine and that virtual machine doesn't have a Wi-Fi adapter because it's a virtual machine. Its context is limited by the host. Or sometimes you want to test a Wacom tablet, or you want to test a Bluetooth device, and these are not directly exposed to the virtual machine. So this idea is that I am going to be able to create a fake Wi-Fi card, a fake Bluetooth device, and have that available inside the virtual machine. So I can test how GNOME Control Center or how the GNOME shell actually reacts to those pieces of hardware, because there are a lot of UI elements. They are conditioned on the hardware that you have, conditioned on the devices that you have. So the ability to create those virtual devices is also pretty interesting. I have lately been in a little bit of technical debt with Boxes, but another plan that I have is to port it to GTK4. I see a lot of improvements that can be done on the rendering part, and also the UI parts. Like now with libadwaita and the GNOME human interface guidelines, I feel that we have also the possibility of grouping way more preferences in a much more manageable collection interface. So it's going to be very convenient for me to add more features to the preferences dialog by adopting the new GNOME style of UI. So I've been catching up with that, and that's pretty much what I wanted to talk to you today, but I'm actually pretty open to new ideas of what features I can add to GNOME Boxes that you folks think that can be beneficial to GNOME contributors, or general questions as well. So does anybody have any ideas or questions?
So anyone from the audience here?
So first of all, thank you for your presentation. So the question is, since you work at Red Hat, where do you draw, or where it's the line draw between GNOME Boxes and Virt Manager? I'm asking because, for example, where I'm working currently, more often than not, I used to do some virtualization, and I need to create some environment where the machines need to speak to each other and that kind of stuff, right? So, for example, one feature that I often miss from GNOME Boxes is, for example, the port forwarding. So in order to enable, the communication between machines and, like you said, right, enabling some virtual devices or some pass-through devices that we can do. So I know that Virt Manager has all these pretty fancy options, but I sometimes find GNOME Boxes lacking that kind of usability. So I don't know if, for example, Virt Manager will continue to be maintained until GNOME Boxes reaches that point, or if that's not even the point of GNOME Boxes. So what's the usability line? So in order for you to say GNOME Boxes will not support that kind of stuff, for example.
That's a pretty good question. Yeah, so I feel the Virt Manager and Boxes are pretty much front ends on top of the same stack, but they have very different user experience designs, right? The idea in Virtual Manager is that you know what you're doing, you know which virtual devices you're adding, and Boxes are going to just figure it out for you, and you actually don't need to bother about that. But lately, I've been actually working on separating the concept of the virtual machine creation and the virtual machine configuration. So at the creation step, you would get the defaults that Boxes define, and you don't actually need to know anything about virtual machine management. But if you right-click on your virtual machine, then I'm going to have a configuration dialog that you're going to be exposed to customize those devices. So if the default assigned virtual video driver is VirtIO, and then you want to change it to QXL or something like this, then you would be able to customize after the fact. But as a new user who has no idea what I'm talking about, you can just go through the assistant, create your virtual machine, and the default is going to work out for you. You also mentioned the question about pass-through. So we currently rely on SPICE for USB redirection, so we can support USB redirection, and we also have the network bridge that allows the virtualized operating system to be accessed from the outside. But that's kind of in a bad shape because it's still up the distribution to set it up. So there's a KeyEmu bridge helper that is this daemon that is responsible for actually providing this feature. It's something that needs to run privileged. And so I know for a fact that Fedora supports this, RHEL supports it, but some other distributions might not be interested on having that binary running privileged. So it's been kind of a problem of inconsistencies, and this is one of the reasons why I feel that the solution to this might be with Flatpak portals, so we can have like a application that is going to talk to a system component that can properly escalate privileges with the user's permission using police kit and things like that. So to wrap it up, I feel that Boxes and Virt Manager are somehow converging into support the very same things, but still in different ways. And I find it actually to be interesting to have the both options in the ecosystem. So I think that everybody benefits from having both.
Great.
My question is kind of along the same lines. I have a whole ton of pre-existing Virt Manager, that I've managed VMs that I've set up with configurations and snapshot histories and all this kind of stuff. I've never tried, and so this may be simple or it may be complex. How easy is it to import those into GNOME boxes, and how much of it just naturally comes over? What will I miss if I view them via GNOME boxes versus my traditional way of managing them via Virt Manager?
Right. So nowadays, it's a very recent feature, but when you're creating a virtual machine in Boxes, you can also select an existing disk of a virtual machine. So if Virt Manager created your operating system and install it on a keycall file, you would be able to point that file to Boxes, and Boxes will be able to run the virtual machine from that state. So you get to preserve your data, you get to preserve the snapshots in Boxes the same way as the ones in Virt Manager. This is a quite recent feature. Yeah, I think that the part you'll be missing currently is the ability to change the configuration of the virtual devices. We actually expose this by doing or by allowing you to edit the libvirt XML. So if you are like very versed in libvirt things, you actually can change that in Boxes already. But yeah, you don't have still like an interface for changing the virtual devices on the UI. But that's specifically what I'm interested in working on for the future, probably GNOME 44, I would say.
Great.
Regarding the virtual devices implementation, are you planning to do something like, I don't know, Android SDK, so like a controller in order to simulate, the things and, for example, adding new devices and simulate it, plug in, plug out, or changing its state, and maybe even like, APIs from GBus APIs to control those, I don't know.
That's really interesting. At first, I would probably just support adding virtual devices that libvirt already has defined, but I think it's actually a pretty interesting next step to provide some sort of API that you can hook up some controller for your device or even do some mocking of certain things. I recently have been working on the GNOME user account fingerprint reader that you also worked on, and that has been kind of a pain to work on with not having a fingerprint reader. So I can totally see where you're coming from, and yeah, definitely that's definitely something I'm interested on.
I haven't tried boxes in a minute, but I think in like the GNOME OS nightly, but like a few months ago, I think the ISO only worked in boxes and not in Virt Manager, and I was curious since it kind of shares the same foundation, why, and if that maybe does it work in Virt Manager now? I mean, I am similar. Like I have lots of Virt Manager experience, but if I can port my my VMs over to boxes, that's amazing. But in the meantime, like, can I like install GNOME OS nightly in Virt Manager?
I think you can. I think that the hardest part is setting up the firmware to UEFI. That in Virt Manager you actually probably would have to create the device and still point it out to the keys, and boxes will probably do that auto magically for you. But that's why we are recommending to use boxes. But yeah, I think you can run GNOME OS in any other virtual machine manager that supports UEFI firmware. The UEFI firmware has been the reason why we recommend it. And the same thing, sometimes you probably heard on the release notes that we are recommending users to use the FlatHub GNOME boxes. It's also because some distributions might not include the bits on the virtualization stack that are required for supporting UEFI firmware, because there's some security layer over there and it's a bit more complex to set it up.
Thank you. So we have a few more questions from our online audience. How hard would it be to add support for older versions, say Windows or Intel macOS versions, whether it's from local images or automated installations like Fedora GNOME OS?
Yeah, it's a question of just us providing the virtual device data to the operating system database that we use. So we have currently having a policy of supporting only the operating systems that are supported by their vendors. So if Microsoft tell us that they are no longer supporting Windows XP, we are no longer updating the configurations for Windows XP. But I can totally see how we could be supporting older devices if we will be willing to actually maintain the database and compatibility with those old devices, but just specifying which virtual devices work with it and which do not.
Great. The other question. I tested GNOME Boxes 42 and wasn't able to pass through my keyboard to a Windows VM for keyboard setup with vendor software. Will it be possible in the future releases? Although I could have passed through other USB devices, such as microphone. Boxes on Fedora Workstation didn't show keyboard in the interface.
Well, that's definitely a bug. It's expected to show.
Great. And what's the GTK4 porting plan?
Yeah, so Boxes uses Spice as to connect to the display of the machine, and Spice does a lot of input. And with GTK4, there was a change from the type of events we were used to hooking up those events to controllers. So Spice GTK needs to be ported, and then Boxes can easily be ported afterwards. I'm not entirely sure if we are going to go that way, because there's recently some very interesting developments in QEMU. QEMU has this new QEMU dbus display, which allows you to actually have access to the frame buffer of the virtual machine. So we are considering bypassing Spice and doing the rendering and the drawings directly on GTK4 without using Spice. So yeah, it's still something up for consideration, but it doesn't depend just on me. It also depends on what the Spice community is interested with the project moving forward.
Great. Thank you very much. I guess these were all the questions we had for Felipe. We have the break now, and we'll be here at 1:30 local time. Thank you.
Thank you.
Thank you, Christy. So before taking away with the presentation, it's the last infrastructure talk that we did was back in 2014. So it's been, actually it was 2016 in Almeria. So it's been a while. A lot of things changed over time, but before going deep into what we did, I would like to mention that right now the team is composed of 2 persons. I'm currently coordinating the team since 10 years. My other colleague is Bart, which is actually managing Flatpak, FlatHub, and also the CI/CD part of the infrastructure. What we did in the last 10 years has been, I would say, to some extent crazy, because we literally moved from a scenario where we had bare metal systems, right? So we were hosting GNOME services on bare metals. No VMs, no containers. That was more or less 8 years ago. No orchestration whatsoever, to a point where right now we're running full containers for all the services that GNOME is running. There's still a few services still on VMs. GitLab, for example, is one of them. GitLab Pages is on containers, so we're moving each of the services that still are on VM to containers. So we're close to be fully containerized. So there's been a dramatic change over the past 6 to 10 years to the GNOME infrastructure. As you can see, these are the core technologies that we're currently using and the outer specifics of the systems that we have. The critical component in our infrastructure right now is OpenShift. That's actually a Red Hat product that is built on top of Kubernetes. Quick note, I'm a principal systems engineer working for Red Hat, also part of the GNOME staff since 10 years. So getting back to the presentation itself, so the core foundation of the infrastructure is on OpenShift. Not sure if you guys are familiar with Kubernetes in general. We'll be having a Q&A session at the end of the talk, so you can ask me anything that you may have in your mind. OpenShift is actually based on Kubernetes, allows us to orchestrate our infrastructure, which means that we can run our infrastructure using the infrastructure as a code paradigm, right? So we're running our repos on GitLab, and anything that we run in our infrastructure, you can find it in our infrastructure GitLab group. One of the main issues that we had back in the days was running a virtualization orchestration system was too much of a pain, right? So in the past, we gave a look at Ganeti, for example. That's a product from Google that allows you to orchestrate your VMs. So you have a web UI or a CLI, you just click create VM with these specs and it creates a VM for you. That wasn't worth managing the actual control plane that Ganeti had back when we evaluated the product. So our decision back in the days was, let's go with VMs and manage them manually, because we mainly had like 5, 6 VM, right? And new VMs, spinning up a new VM was happening like every 6 months. OpenShift with the 4th release also comes with OpenShift virtualization, which allows us to orchestrate the virtualization component. So you've got your CRDs, your Kubernetes CRDs, you define a CRD for your VM, and it automatically provisions the storage for you, it creates the VM, assigns the networks, and you're actually live with a system running RHEL. The storage component that you see there is Ceph. We'll be going through the details of how Ceph is currently deployed and what services we're taking out of it, out of Ceph directly. Of course, GitLab CI and CD. For Quay.io, we had some, not bad experience, but we were running our own container registry with OpenShift 3 that takes out a lot of storage, several terabytes. So we decided to just use Quay.io that is provided for free when you want to use public repositories, right? Given that anything that we manage is public, from former Puppet repositories that we have, or Ansible repositories, or any other service is currently public, we don't care about having our container images being public as well. From a monitoring standpoint, we were using Nagios. We moved to Prometheus Alert Manager to have metrics and monitoring based on metrics, right? Rather than having Nagios that pulls data every 5 minutes and alerts every 5 minutes. And what happens in those 5 minutes time interval, you don't know. Right? So with Prometheus, we collect samples of metrics every 10 seconds. Yeah, the hardware specs, as you can see, we don't have many systems. They're particularly powerful in terms of specs, so there are plenty for running all the GNOME services. All these systems are currently hosted in Raleigh 3, that's a community data center that Red Hat has. So let's move to the architecture of the infrastructure. So for OCP4, for OpenShift 4, given that we're running a small edge site, we have the control plane living on the same systems as the workers, right? We don't need to have dedicated workers. So OpenShift comes with so-called memory and CPU reservations. That means that you can say, I want these bare metals to only consume this amount of memory and this amount of CPUs and reserve a specific set of cores and memory for control plane containers, right? That to avoid the workers to actually, the containers that are running the apps for GNOME to actually go and destroy the control plane whenever they exceed the memory or CPU reservations. So from a control plane standpoint, it's all running on containers. It's all, there's a set of operators running on top. That's a dramatic shift between OpenShift 3 that we were running till 6 months ago and OpenShift 4. Operators allow you to create objects, and like you do in programming, right? You have a specific library. You can create an object out of that library. It happens the same with operators. You have a set of classes, and you can create objects out of those classes. And you can think of a class, right? For example, a storage volume, right? I need a storage volume. I just create an object definition, insert it into the API, and the system will get you a volume or a VM or a container or a deployment config, any Kubernetes or OpenShift related resource, it will get out automatically for you. The current pain point is the fact that we're using DNS round robin for load balancing. That's a problem because whenever one system goes down for maintenance, we would have to automatically remove it from DNS. That's a pain right now, and it doesn't scale. We got in touch with one major load balancer vendor recently. Recently, I wasn't able to update the presentation, but recently it was like yesterday. So as soon as I'm back, we will be discussing a proper load balancing solution, right? That will allow us to have health checks and remove from the pool the node that is actually under maintenance, so that no traffic is ever lost. As I was mentioning before, we've got Rook. Rook is actually a storage automation solution operator. You can actually get any volume type out of Rook. You can get also, for example, Rados Gateway out of it. What's Rados Gateway? Rados Gateway is actually an S3 compatible interface. You can get a bucket and it will behave like S3, right? It's an API that is fully compatible with S3. So you can get a bucket and use that bucket for whatever you would use a bucket for, right? Registry or any other service that, for example, GitLab right now allows you to store data into an S3 compatible bucket, right? So in theory, we could use Rook to have a bucket provisioned and consume it. The important piece of this specific slide is the infrastructure as a code that I mentioned earlier. How does it work? Is that we're leveraging the CI/CD of GitLab to effectively build an image that is then pushed to Quay.io. From Quay.io, from the OpenShift side of things, we use image streams. Image streams are a way to keep track of an image status, okay? So the image stream will check the remote repository, the remote registry, and will tell, is this the latest digest for the image or not? If it's not, and I have a flag set to schedule being true, which means check periodically. If it's different, I want the image to be updated, right? Let's say that, for example, from a security standpoint, we run daily builds, automated daily builds that take the latest image, applies package updates from the Debian or RHEL, whatever repos. It spins up a new image, pushes the image. The image stream notices that there's a new image pushed there, and automatically the deployment config of this specific application will grab the container image and roll out the new image to the public automatically. This is useful, as I was mentioning, for security updates. It's also useful in case, for example, GNOME events. The GNOME Events app that you've been using for GUADEC requires a new update, right? New release, security update, whatever. From a Ceph perspective, Ceph is actually a software-defined storage solution, right? Given that solutions like NetApp cost a lot of money, Ceph allows you to use bare metals that you will purchase from any vendor, HP, Dell. In our case, we're using Dell, and use those systems to effectively provide an API that you can use to provision volumes. As you can see, you've got block, so any block device that you can plug into your VM or container. You can use Rados Gateway, S3, which is the S3 compatible interface that I was mentioning, and also CephFS. CephFS, you can think it as shared network storage. Another network-based storage that you may know is NFS, for example. SFFS, it's actually similar, right? It's a different interface, but the concept behind it is the same. Regarding GitLab, right now we're running on a VM, pretty much all the services, but GitLab Pages. We tested GitLab Pages on OpenShift recently. It's working fine. So we'll be moving more components of GitLab to OpenShift in the coming weeks. I believe when you talk IT, one of the core components is definitely monitoring and alerting, right? We shift our paradigm from Nagios, where we had a set of monitors which were pulling data every 5 minutes or more, to a paradigm where we have metrics being collected every 10 seconds, as I was mentioning earlier. These metrics are collected from all the systems that we run and also from all the services that we run. For example, the service that we're running for GUADEC that you're seeing here, which is big blue button, as a Prometheus exporter. So we exactly know how the conference behaved over time. How many people joined, how was the latency. We can see whether the latency went high when more users joined the platform. We can understand when the platform starts having some limitations, right? Let's say that GUADEC, 1,000 people will join remotely. We start seeing that the VM behind it is having issues, right? And having issues, I mean memory or CPU constraints, right? We can understand that before the problem happens and upgrade the box or move some services to OpenShift or move them to a better proper platform, right? How we do the alerting? We do the alerting thanks to Alert Manager. Alert Manager is mainly composed of a set of rules. You apply a set of mathematical functions to data, and once they cross specific thresholds, we get an alert, which is sent to PagerDuty, which is our phone, right? From our phone, we can then assign the incident to someone else in case you're on PTO or you just need help or you're not close to a computer. We also do latency monitoring, and latency monitoring, for obvious reasons, it's running outside of the main data center. So we have one of our sponsors provides us with a box that we use for doing latency monitoring. And latency monitoring is actually useful to understand, how the application is performing over time. And it's also useful for understanding how good we're doing in terms of certificate management, right? We are running a fully automated certificate management, which means that we don't care about SSL certificates anymore, right? We don't care about having to renew those certificates because the platform handles that for us by using Let's Encrypt, right? So there's a specific operator that handles rotating the certificates whenever they're close to expiration, right? Back in the days, the process was automated, but it was really error prone because of multiple reasons. Right now, it's fully automated, and we're getting out of running with wildcard certificates, which pose a security risk because the certificate management allows us to automate it, all of it, without caring about the technical side of things. since 2016, a lot have been going on. Some of the information that you see in the slide I already mentioned. But the second bullet point that you see, OC3 deployment and mass migration, has been a massive work, has been really, really a dramatic and important work that we did during the past 3 to 4 years. We had a set of VMs. We were trying out containers running out of plain Docker. As soon as we found out that running Docker containers was fine for us, but we needed to evolve, right, to an orchestration platform, we moved all our services to OpenShift 3. OpenShift 3 doesn't come with the concept of operators. So some of the orchestration behind it, for example, certificate management, was happening using Puppet, which was our former config management tool that we were using. We're still using to some extent. The main issues with OCP3, not the issues, I would say more limitations, is that you need to run a fully managed operating system that's different from OpenShift 4, for example. OpenShift 4 is running CoreOS. CoreOS is the former OS3 based operating system, which means that all operations in the system have to be, for example, when you want to upgrade the system, the upgrade procedure should be actually atomic, right? For atomic, I means if it fails, it will be rolling back to the previous version of the tree. If it succeeds, it will promote the tree and use that tree for running the actual system at the next boot. The great advantage of running CoreOS is that you don't have to manage your operating system anymore because it's entirely managed using the machine config operator. So you mainly define a couple of objects and it will be modifying and customizing your OS for you, right? You don't care about having Puppet on the system. You don't care about having Ansible on the system. It's everything managed using the machine config operator. That means that we were able to retire like 10 VMs, which were the infrastructure nodes, worker nodes, and control plane nodes that we were running with OCP3. So a lot of time that we're currently saving from managing these systems. As soon as we did the migration to OCP3, three years ago, the deadline for moving away from it was June 2022. We had to shift to OpenShift 4, and so we did. The migration was actually extremely successful. We're using operators, we're leveraging all the new technologies that OpenShift 4 provides, and it's really saving us a lot of time and pain. Retiring OpenShift 3 also is allowing us from using RHEL 7, which will be end of life as well soon. So we're moving to RHEL 8, RHEL 9 everywhere, wherever we need a VM, for example. We're moving from Puppet to Ansible, so we were using, since early days of the GNOME infrastructure, Puppet was in use. We're moving to Ansible, like we have a good bunch of more roles and modules already created. We're close to complete the migration and fully retire Puppet altogether as well. The other good thing is, thanks to CDN 77, we were able to move all our static content to a CDN, which is a major success for us because we don't have to spend the bandwidth to support some of the downloads. For example, think about the GNOME OS images, right? This is actually saving us from having to serve all those images directly from the GNOME infrastructure itself. So moving to the other core component of the GNOME infrastructure, right? So recently, in the past 4 or 5 years, since we introduced GitLab, we also introduced the concept of CI and CD, right? That's being heavily used by all the GNOME contributors and devs that use GNOME GitLab. We've been evolving the service over time by providing more architectures and more runners per architecture. As you can see, for example, the Oswald's managed runners or anything Oswald's, which is one of our sponsors, they provide us with VMs and build infrastructure. As you can see from this data, we're really seeing a lot of usage and a lot of builds per day, and we're seeing these builds increasing heavily. The more the GNOME ecosystem is growing, the more these runners are being utilized, and the more we need to come up with better plans to support, right, GNOME devs and contributors to have, faster builds, more architectures to test against. Generally, the more quick the build is, the more the GNOME devs can actually focus on code, right, and actually see the results of their changes. So it's important. It's really important for us, GNOME infrastructure, to provide runners that are quick, supported as possible. Same topic. Our achievements with the CI/CD things. One of the main problems that we were having running Rails 7, or better, CentOS 7, on these runners was that whenever a GNOME module was coming out with we were requiring a new syscall for one of their tests, for example, the build was failing. We needed a more recent kernel running on these runners. So we actually redeployed our runners altogether to use the latest Fedora release, so getting the latest kernel available in there. We also added some garbage collection. One of the problems that we had was these runners were going constantly out of space in early days. Right now, we have garbage collection running on them, which means that we don't care about runners anymore. They just run. We have a periodic job that makes sure that these runners have security updates and are rebooted, and they're disabled from the GitLab, rebooted, and put back into service. We don't care about cleaning up space. We don't care about managing these runners anymore. They're actually doing what they're supposed to do without taking in additional maintenance burden to us. They were made shared because of the fact that more sponsors provided more compute power. We decided to have these runners to be shared, right? So even if your project is not part of the GNOME group, you can benefit from the GitLab CI and CD as if your app was actually part of the GNOME group itself. So what our future plans are? We plan to effectively retire Puppet, which has been running in the GNOME infrastructure since the past 12 to 15 years. It's running an obsolete release, which is Puppet 3. I believe right now there's Puppet 7 or something. So it's running on an obsolete release that we're only keeping around because it's supported because of RHEL 7. The plan is retiring it altogether and moving to Ansible. What's missing in there is just building up a few roles and moving the system that are using Puppet to use Ansible. So nothing major, but something that is possibly going to require 1 to 2 months, nothing too crazy. As part of Puppet, we also had, as part of Puppet and the former storage infrastructure, we were running GlusterFS, which is being retired. It's a product that is not being, it's actually being maintained by Red Hat. No additional features are being developed in there. It's going to be retired from upstream really soon. So we only have the Puppet storage running in there. So as soon as Puppet goes away, GlusterFS is also going away. OS currency is another thing. We are actually retiring all the RHEL 7 system and building up RHEL 9 systems, which came out 2 to 3 months ago. We want to move GitLab to OpenShift in its entirety. That's an item that I've been mentioning a few times already. We want to move our centralized logging system to use Loki, which is a tool that is built by Grafana. The idea is reusing the data that we collect from our syslog, collect that information and make something useful out of it, right? Like, for example, how many users are downloading the GNOME OS images, how many users are browsing the GTK documentation, and providing this data to anyone in the community requiring it. I'm not saying that we don't have the data. We do collect the data. We're not effectively making good use of it because we need a new tool, right, to actually collect information or big data out of those gigs of data that we collect every day. Databases right now are running on a bare metal system. We want to move to use the Postgres, SQL, and Galera operators that OpenShift provides. Deploy the load balancer in front of a CPU4. That's something that we seem to have got a sponsor for. So that should easily be close to complete. The solution that we use for identity access and management is called FreeIPA. It's actually a solution that is built on top of multiple open source solutions, including, for example, Directory Server. That is actually a product based on top of OpenLDAP, right? So we've got OpenLDAP, we got two-factor authentication, we've got a web UI that you can use. So it's a fully automated identity access and management system. If you ever accessed account.gnome.org, you know what it is. It's actually running free. It's actually running FreeIPA. If you're following the path, you've understood the fact that the GNOME infrastructure is moving towards an idea of having self-service for every service that we actually run. So OpenShift, for example, and I'll be at it after this slide. With OpenShift, if you have a GNOME account, like if you're a GNOME dev, you can access OpenShift now. You can create a container, serve your application, or you can create a VM, and you can test your stuff in there. And it's all self-service, right? We recently introduced the password reset app. For example, if you don't remember your password for your GNOME account, you can get it in an automated fashion. The only part that is currently not automated is the account management and the membership management. We'll be providing a tool that actually automates that part. So you will just create a new membership application. There will be some automation running behind the scenes, and the membership committee will just have to do, accept or deny the membership. And the person will have an account created, a GNOME.org alias, and all the other goodies that we provide to foundation membership. The same applies to GNOME accounts. Right now, you need to open a GitLab issue. A maintainer needs to come in and say, I want the person to actually access the GNOME group in GitLab. That doesn't scale, right? So we'll be automating that part so that we automatically mail maintainers based on the dope file that you see in each of the repos under the GNOME group. And the maintainer will just come in and say, I want this person to have access done, complete. So the accounts team will not cease to exist, but it will have a reduced focus, right? Because finding contributors and voluntaries to actually manage this kind of stuff is hard. So we want to drop that requirement and automate the whole process. This is what I was mentioning regarding OpenShift and self-service. If you guys are interested, you can reach out to me. I'll just explain a couple of things to you, but right now you can already access our OpenShift instance using your GNOME credentials, right? You don't need to do anything other than logging in. Once you've logged in, you can directly create a VM. You can directly create a container. You can expose services on the internet without requiring additional intervention from our side. The only gotcha here is you're not allowed to create anything that is not related to GNOME, right? So it needs to be relevant for GNOME. It needs to be for an app that the GNOME ecosystem and the GNOME Foundation and project will actually take benefit from. Quick overview about our sponsors. So Red Hat is kindly sponsoring our systems. The new systems that we got were shipped like 6 months ago. They actually, with these systems, we were able to deploy OpenShift 4, move to OpenShift 4. Also, we get unlimited bandwidth. We get unlimited sponsorship against any of the Red Hat products, right? So if we need a Red Hat product, let's say OpenShift, we get it for free. It's sponsored by the company. Also, thanks to AWS, they've been great because any amount that we requested was kindly granted. The way it works there is we explain our projects at the beginning of the year, and we create like a budget request that is documented based on S3 usage, EBS usage, EC2 usage, whatever that we'll be using, and AWS is kindly sponsoring that for us. Also DigitalOcean that we use for some of the runners. CDN 77, as I was mentioning, it's our current CDN solution. They're actually providing unlimited bandwidth, which is crazy. And also Open Source State Lab in Oregon, Fossos, CodeThink, Equinix Metal, and Canonical. They're kindly providing us with GitLab runners, right? Those are a precious resource that we're using. So a big thank you to all the sponsors for helping the GNOME infrastructure being what it is today. And that was all. Do you have any questions?
Regarding to the fact you said the CI images and garbage collecting, that means that basically when we manage a project, we use, for example, the templates from FreeDesk, we can just basically ignore the fact that we might fill up the space and you handle the thing when all the, for example, revisions we won't use anymore will.
Exactly.
Yeah.
That's a good point. The way it works is there's a set. So the way registry works and images, container images work in general is that you've got multiple digests, right? Whenever a new digest is out, because the free desktop image comes out with a new copy, the old one remains in the system. It just gets untagged, and the new one gets tagged with the new tag that you're supposed to the runner is supposed to use when building when performing the actual build, right? What happens behind the scene is that the service will check for those untagged images or for images that haven't been used for a long time, and it will be removing them. So it helps with free desktop images which are pretty big in size, right? To make sure that the runner doesn't fill out of space and it stops working, right? It's not 100% perfect yet, but it's working fine. I mean, the reports that we had about notice space has been pretty rare. They were really frequent at early stages of GitLab. Right now, they're pretty rare.
We have a few questions in the chat.
The first question is a very good point, actually. So in certain scenarios, we actually had to provide so-called privileged runners because there was actually no way for us to provide a runner with those specific syscalls without the runner being privileged, right? So we run a couple of privileged runners. Those privileged runners are actually bound to the GNOME GitLab group only, which means that if you're not part of the GNOME GitLab group, you won't be able to use those runners, right? The idea is running with security profiles that have the least amount of system calls available, right? So from a sanitizer perspective, what we do is run a security profile on Docker Podman, which comes with the least amount of permissions. Whenever the build fails because it requires a new syscall, we make a security evaluation, and we eventually include that syscall into the profile, right? That's how we do it. Keep in mind that all our GitLab executors are based on Podman or Docker, right? So all the builds are running into running in a containerized environment. That's the second question is actually a nice question. What we've tried doing around that has been building templates. So for example, let's say that you're interested in building up an app, and that app is then going to be deployed on OpenShift, right? We don't expect you to be able to write that from scratch. We've got a template that you can use. So I'm not particularly familiar about free desktop and stuff templates because that's something that Bart is managing. I can talk about the OpenShift templates that we're using. I can tell you that you can quickly use those templates to build up an application. and serve that application on OpenShift. So again, reach out to me and I'll provide all the information.
Thank you so much. The new architecture for printing and scanning, what GNOME and GTK developers need to know, by Till Campeter.
Hi, I will talk about the new architecture of printing and scanning. Not many people here. I think the post-apocalypse talk in the other room did not stop, and they do not come over. But I will start now. Und schöne Grüße auch nach Berlin in die C-Base. Ich bin kein Berliner, aber ich habe da 7 Jahre gelebt. And now we start. So, first slide. Yes, it's about the new architecture of printing and scanning, and especially what is important for GNOME developers. So it's of 4 parts. At first, I will introduce into the new architecture. Then I will talk about printer setup tools, and I will also report about our development on the GNOME Control Center. And then about print dialogues and the common print dialog backends. And in the fourth part, I will also talk about sandboxed and distribution independent packaging, which is also some important subject also related to printing. So for 22 years now, since I'm working with printing, and I'm the printing guru for Linux more or less, CUPS with its 1.0 launch uses principally the same architecture. In that old times, in that dark times of printing, we had Unix machines, data centers, printers for text and graphics were usually PostScript laser printers. So PostScript was a standard job format. And so applications for Linux and Unix produced PostScript as its output, and CUPS, how Mike Sweet has released it, turned everything into PostScript, all input files, also if there are other original formats, processes the PostScript, for example, for 2 pages per sheet, or for selecting certain pages, and then sends it off to a PostScript printer, or if the printer is not PostScript, sends it through further filters for getting the printer's native formats. The further filters are also known as printer drivers. So the capabilities of the printers we need to know so that we can send print jobs to them. And these capabilities, they were in CUPS described by PPD files, PostScript printer description files. For a PostScript printer, the manufacturer provides PostScript printer description files. For that printer, they were designed for PostScript. In 1984, after 1984, they were even not further developed anymore. And these are text files, so one can they are easily both machine and human readable, and they contain all user settable options and also printer capabilities like color or black and white, or what other paper sizes supported, and so on. And it's simply a static text file. What is that? I did not advance. And to cover non-PostScript printers, the PPD format got extended by Mike Sweet, the author of CUPS. He added a line to these PPD files, starting with the word CUPS filter, and this specifies a filter through which the data has to be sent, for turning it into the native format of the printer. And so a combination of such a PPD file with its filter makes up a classic CUPS printer driver. And usually for this process to get any other format out of PostScript, one usually used GhostScript. And the print queues in CUPS were manually created or through a printer setup tool. The user selects a discovered printer and selects an appropriate PPD file for it. The PPD files and their driver filters come with the Linux distributions usually. So, and now we have this for so long time, and with PPD files from 1984. This is old. This is very old. They were already obsolete when Mike Sweet introduced them with his first CUPS. And then in 2006, Michael, Sweet, and me, we have agreed on abolishing PostScript as the standard print job format. And in 2010, 2011, when CUPS filters came out, it was at the time that distributions used PDF as the standard print job format. The CUPS filters was made up for using PDF as the central format for processing, and the applications, they send PDF. I've talked with GNOME, GTK, and Qt and others, so that they switched their applications to PDF, and they did so. And then PPD files, and also PPD files represent the options either as enumerated choice, so that for the options you have a certain list of choices, or as Boolean, which is yes, no, on, off. And this is not enough. Often we want to have some adjustment. We need a color adjustment, or so we need a numeric option. Or we want to have a fax number or password as an option. And so we need something more flexible. So we want to really, after getting rid of PostScript, we want to really get rid also of the PostScript printer description files. And Michael Sweet has already deprecated them 10 years ago, but there was no concept to replace the classic printer drivers yet. And so we will get a PPD-less CUPS. We are all IPP now. So CUPS only will understand IPP drivers and not support classic printer drivers anymore. This will happen in CUPS 3.0.x, the third generation of CUPS, and the first release will be end of next year, so in 1.5 years from now. So it's not much time that we all have to prepare for the new architecture. So this CUP, and also the CUP Snap, which is already available and ready to use in the Snap Store, it does not allow to add PPD files and drivers to it because it has an immutable file system. You cannot add filters and PPDs for your printers to it. And so the CUP Snap is a nice rehearsal for the new architecture. So when you use the CUP Snap as your default printing environment, you cannot install classic drivers too. So the new CUPS 3.0.x will now only see driverless IPP printers. Will only support driverless IPP printers and not printers which need drivers. Modern printers are all driverless, and driverless is principally always the same. Printer advertises itself by DNSSD. Printer understands IPP2.x, and printer uses one of 4 page description languages: PDF and Apple Raster, PWG Raster, PCLM, and the flavors of driverless printing are called IPP Everywhere, AirPrint and Mopria, and especially AirPrint is very common because of iPhones. And in these CUPS, we will no manually created queues anymore. CUPS will automatically discover the driverless IPP printers, and then they are available. And it will do filtering only what's needed for driverless printers. It will generate the languages which I've mentioned out of the input data. It will not contain any filters which are classic printer drivers. And for the legacy and specialty printer, old printers, or Braille embossers, or certain large format printers, and so on, for these printers, we need still printer drivers, but we need a new format for the printer drivers, the so-called printer applications. A printer application is a daemon which emulates a driverless IPP printer and internally passes the jobs on to the printer which needs the driver, so internally does the needed filtering for the printer's native language, and it answers IPP requests for the capabilities appropriate to the printer's capabilities. So it knows internally the printer's capabilities. So here's some graphics. This is the current old CUPS architecture. We have a user application which sends a job and also requests information which printers are available and which options they have. And the blue thing is the CUPS daemon. And the CUPS daemon itself, without any special extra software, can print already to driverless IPP printers. The current CUPS fully supports driverless IPP printers. And when we have a PostScript printer, then the current CUPS uses PPD files, and it always used them. And we have another printer, which is not PostScript, but needs a driver. Then we have a classic printer driver, which is a PPD file plus a filter. In the new architecture, we have also the printer application, and we have also the user application, which sends print jobs and gets information about the printers which are available, communicates with the CUPS daemon, but the CUPS daemon only knows driverless printer, IPP printers. So we have here the CUPS daemon directly communicating with a driverless IPP printer. Now, if the printer is a PostScript printer, we cannot put a PPD into CUPS. We need to emulate a driverless IPP printer. So we get from the Snap Store the PostScript printer application, which emulates a driverless IPP printer. The Snap contains around 4,000 PPD files of PostScript printers, which are the same which come with Linux distributions, and it contains also the filters to turn the input data into PostScript. And this way we can print on a PostScript printer. And if we have any other printer, we take an appropriate printer application. There are 4 others in the Snap Store: the GoScript, the HPLIP, the Gutenprint printer application, and also LPrint. And with these printer applications, we can print on the other printers. The printer application which we have in the Snap Store covers everything of printer drivers, which usually comes with Linux distributions. So driver-wise, we do not need to fear losing anything when we do the final switch over into the new architecture. So this was the new architecture. And now we know that for the current printing environment, for the current old architecture, we use printer setup tools like System Config Printer or GNOME Control Center, the print module in it. This is the most common probably. And the web interface of CUPS, command line tools, and even CUPS Browse is also a printer setup tool. It's only fully automatic and non-interactive. And these tools control CUPS, the running CUPS daemon on the same local machine. And these tools, they list the available printers and drivers, so the discovered printers, which are connected on USB, which are in the local network, and so on. And it lists the drivers which are installed on the local machine, usually by RPM or Debian packages. And it creates print queues, manually partially automatically, fully automatically. And it lists also the queues, the existing point queues, which are already set up. It lists the jobs which are currently pointing on the queues. It allows to modify the queues, for example, setting option defaults, changing the driver, and it also, at least sometimes, gives access to some server settings, like turning on and off debug logging, turning on and off pointer sharing, and so on. And in the new architecture, we cannot manage the pointer that way, because we have no pointer drivers, we cannot set up queues manually. The CUPS queues every CUPS queue is automatically created for any IPP point service, either an IPP pointer in the network or a pointer application. And so it does not make sense to manually modify the CUPS queues or to directly list them. So as all pointers for which we see in the old architecture CUPS queues, and in the new architecture too, because CUPS automatically creates them. These are IPP services, so it makes much more sense to list the IPP services directly, and to put buttons that you, for example, can access the web interface of the IPP service. Every IPP point service has a web interface. You know, pointers have a web administration interface. And you know also that, and pointer applications have also a web administration interface. So it makes sense to give access to that. And also every IPP service can also be controlled in a certain range also directly by IPP. This is called IPP system service. So we can also put another button to get into an IPP system service interface. And then for printers, you know that in a printer setup tool, you have the add printer button. It's in the top, in the title bar in the GNOME Control Center, if someone didn't find it. And if you click it, you see discovered printers, and you can set up queues for them by clicking the discovered printers and following the wizard. This is also not making really much sense this way for the new architecture. In the new architecture, we have to list printers which we discover, which are not driverless, which we can only make printing if we connect this printer to a printer application. And if the user chooses it, we need a way to find a printer application for it, not to find a locally installed driver, but to find a printer application. Once locally installed printer application, but also a query on the internet, on an internet service, which printer applications are there and which is the right one, sending the printer's device ID to the service, and the service answers which is the correct printer application. This service is under development. It will be part of the Open Printing website. So here's a little bit of a comparison. Before, we listed CUPS queues and had buttons to modify the queues in terms of changing driver, changing option settings. After, we will list IPP devices, IPP services, and buttons to get into web interface and IPP system service. And add printer, before we listed printer devices and drivers, so that the user could create a CUPS queue. And now we list non-driverless printers and present an interface to find printer applications. And if we have found printer applications, we present buttons to get, for example, into the web interface of the printer application, so that one can there configure the printer. And one thing is we have multifunction devices which have a scanner of hex in it. A printer setup tool could list this functionality too, but it's not absolutely necessary. It depends on how you think is what's the best design for a user interface. So, and now the new printer setup tool is already in the works. In the Google Summer of Code 2022, we have 2 Google Summer of Code contributors, not students. They've changed contributors, which means starters in free software. And they are working on the 2 main pieces of the printers module of the GNOME Control Center. But they are not replacing the printers module. What was our idea before, in the years before, and when in 2 schools of codes already some part of the code like listing IPP services, entering the IPP system service were already written. We have changed the design a little bit. We had a lot of discussion with Marek Kasik, the maintainer of the printers module of the GNOME Control Center, the 2 students and me, and we have settled on a design that the module gets the items for the new architecture simply added. And so it supports both the old and the new architecture, which means that if you replace the GNOME Control Center first and we replace CUPS after, the user will not see much change. It will simply just work all the time. And so the GNOME Control Center is about to get added. It does not list only CUPS queues, but also IPP services, and it naturally does not list both the IPP service and the corresponding CUPS queue to not confuse the user. And in the add printer module, it discovers also printers, but it is capable to install them with printer applications or to install them with classic drivers. And if the underlying CUPS is a new CUPS or the CUPS snap, then the old stuff, the permanent CUPS queues and the possibility to install a classic printer driver will simply not be displayed anymore. And so here you see the Google Summer of Code efforts. Oh, sometimes it advances by itself, but I wanted to advance anyway now. Here. And so we have really the smooth transition. It's Shivan Mishra, the first contributor who does the main panel, the listing of IPP services, and Mohit Verma, who does the extension of the add printer window to set up printers with printer applications. And so we have now, and they are very well in shape with their work. I'm communicating a lot with them via Telegram. There are 4 feature requests on GitLab, which describe the tasks which are working on, and Marek Kasik is discussing with them on these feature requests, and me naturally too. And so we are working on designing and changing and updating the GNOME Control Center for the new architecture. So with this, I'm also a little bit getting a GNOME. And if all works out, by the end of the Google Summer of Code, we have the code for the new architecture in the printers module, and this is supposed to get upstreamized to get into the GNOME Control Center code base, so that future Linux distributions have it simply available. And I hope with this that I can switch the Ubuntu 23.04 to the CupSnap as its main pointing system, and so switching over into the new architecture. And here, the 1878 is the most busy currently. It's about adding the printer application support, and the other three are for the main panel. And one thing to mention, we will not list scanners in the printers module of the GNOME Control Center, because the user really does not think in IPP services. He thinks more in devices or tasks. This is a printer, this is a scanner. And therefore the scanners will not get listed. So the other thing is, the other part of GUI for printing is the print dialog. And on the print dialog, we had a little problem because CUPS has advanced. It got new features and new functionality, and the print dialog was always somewhat behind. One special thing is the temporary queues of CUPS. If you have an IPP service in your network, CUPS creates a temporary queue for it, or CUPS clients via the CUPS API create a temporary queue for this device. So CUPS does not need to have a permanent queue for an IPP service, because simply when one uses the CUPS API and one sends a job, the queue is automatically created. CUPS gets at first a command to create the queue automatically. Then the job is executed, and when the queue is inactive for 1 minute, CUPS removes it automatically. But this requires from the client to use a new enough API of CUPS. Otherwise, this does not happen, and the printers are not listed in the print dialog, which has led me to overcome this with CUPS Browsd, by CUPS Browsd doing the automatic creation of the queues. But I want to get rid of it. I want to have it working as Mike Sweet has designed it. And in the GTK dialog, recently this was fixed already. The GTK dialog now lists the temporary queues and prints on them. But it's an example that GUI development is often somewhat behind. And so in 2017, I came and the next step, the new architecture, we do not support PPD files anymore, which means print dialogs have perhaps always to again to change. Perhaps some PPD dialogs, I think the GTK dialog is not one of them. Read directly the PPDs from the directory /etc/cups/ppd, or download the PPDs via HTTP from CUPS. This does not work anymore in the new architecture. Some browsers like Chromium do it, and so you cannot print with a Chromium dialog when we switch over. And so these are some problems with print dialogs and the underlying print technology. To overcome it, I came to an idea in 2017 already, and this is the common print dialog backends. And the trick here is that we move the responsibility. The direct access to the print technology should not be in the dialog from Qt or GTK or Chromium anymore. It should move to where who has created the print technology. CUPS is part of open printing. So we do the following. We have a backend with a dbus in. We have backends with a dbus interface, the so-called common print dialog backends. So for CUPS, the backend is maintained by open printing. So when something changes in CUPS, we change also the backend appropriately. It has a standardized dbus interface. There's also another interface, another backend maintained by open printing for print to file. And if someone would introduce a new print technology, like for example, a cloud printing service, then this someone could create their own backend and with this get their technology also in all the print dialogues. And the backend is dbus coupled to the dialog. So the backend can be in a separate sandbox, a snap or so, then the application. And so the provider of the cloud printing service can simply put it in the Snap store, and so everyone can make use of it. And the print dialog naturally needs an appropriate interface that this works, so that the print dialog does not access CUPS directly anymore, or accesses CUPS with its own backend. But this own backend of the GTK dialog works only in the GTK dialog, but not in the Qt dialog. This is not cute, and also not in Chromium. So we have the common print dialogs common print dialog backends interface, and this we want to get into all print dialogs. And for this, I have also a Google Summer of Code contributor who is working on that. Yes, here is the original Google Summer of Code project where the dbus interface was created by Nilanjana Lott back in 2017. And this is her original sketch. And we have already most of the code on open printing. There's CPDB libs. These are the libraries for both the dialog and for the backends, which make up the dbus interface. And we have the two backends for CUPS and for file. And they are already there. They are improved and debugged by the Google Summer of Code's contributor. And also the contributor has nearly completed the GTK dialog support and is soon starting on the Qt dialog. And so we will get this problem solved in the print dialogs. And yes, this I have already taught. Yes, and now, you know, now another field of interest for the printing, how we distribute applications, and ideally distribution independent applications. We want to distribute applications, user applications, many of them print in a distribution independent way. We also want to distribute CUPS in a distribution independent way, so that you can always have the newest CUPS, even if your distro does not have it, or if the CUPS you want is newer than the distro you want to continue to use. So only for CUPS to change the distro, this is not needed anymore sooner or later. And also the printer drivers. It is very important that we can distribute them in a distribution independent way, so that the manufacturer of a printer puts out one printer driver package and it works with nearly all distributions. So that they do not need to test 20, 30 distributions whether it works and have separate packages for them. or try to make packages on their own which work with many distributions. This causes a lot of problems, and so distribution independent packaging helps us. And so I will talk a bit about the methods of distribution independent packaging. The first one is Snap. Snap is very similar to smartphone application packaging. We have sandboxed packages. Each package has its own file system, a static, immutable one, but also a dynamic one, but it's completely enclosed with the help of AppArmor. And so it cannot, the snapped application cannot access the host system and cannot access the file system of other snaps. And Snap is the most sophisticated method of distribution independent packaging, which I will tell here now. First, we have the security concept that the file system is and the access is completely isolated, but we cannot stay totally isolated. We must communicate with the host system to get into the internet, to get access to keyboard and mouse and to the screen. And sometimes we must communicate between snaps, because when we want to print from one snapped application, we must be able to communicate with the CUPS snap to pass on the job. So we need interfaces. And the interfaces are well-defined, well-defined exceptions for the rules. So when you build a snap, you select interfaces, you connect interfaces, and when you connect an interface, then the rules of the interface apply, and so the snap is allowed, for example, to connect with a network, to see the DNS SD broadcasts, to connect with a D-bus, to connect with CUPS, and so on. And so we have interfaces, but the interfaces, they are different. There are two sorts of interfaces. There are safe interfaces, like the interface named CUPS, which allows to print on CUPS, but only to print on CUPS, not to create queues and modify queues, not to manage CUPS. And so it's a safe interface. And if you have your snap, if you make a snap of an application which prints and put it into the Snap Store, then and it connects to this interface, when the user installs it, this connection is established automatically, and after installing this application, the user can immediately print. Because this is a safe interface. When you can print with this, you cannot break anything. Then there are dangerous interfaces. For example, CUPS control. This is the other interface to connect to CUPS, but CUPS control allows everything on CUPS. With this, you can create queues, you can stop and start the CUPS daemon, you can switch to debug mode, you can read every user's jobs, you can delete every user's jobs. So CUPS control is dangerous. It is an interface design, it is an interface we use if we snap a printer setup tool. And because it is dangerous when you install an application which connects to CUPS control, this interface is not actually automatically connected by just installing the application. You have to manually connect it after installing the connection. Or the SnapStore team has given special permission to the author of the application for auto connection of the interface. But this is not the case for all applications, and the SnapStore team is also reviewing the applications before giving that permission. And with this concept, Snap is a very, very secure platform. With this concept once of the SnapStore, and also with the dangerous and safe interfaces, and that the dangerous interfaces can only auto-connect with special permission of the SnapStore. And therefore, free software project can very easily snap their application and upload it into the Snap Store, and users can, with confidence, install this application, and it's distribution independent, so they get a lot of applications and independent of their distro. So, for example, with this, they have always the newest Firefox. Also, if their distro is already 2 years old, or the newest LibreOffice, or they have something like FreeCAD, which is for which perhaps there's no Debian RPM package or so, or the Debian RPM package is not well maintained. Because on snaps also we try that the upstreams maintain the snaps, not the distros. So for application snaps, it should be usually the case that the upstream project is maintaining the snap and not, for example, Canonical or Ubuntu. Even the snap stores from Canonical, but snaps are not Ubuntu. Not a little bit Ubuntu is in them because the base distro of them is Ubuntu, but they are not not really a part of the Ubuntu Linux distribution. Yes. Oh, completely about 5 minutes or so. Yes, I think I would be informed 5 minutes before, so. But we are in the end of the day, we can, yes. Yes, yes. Yes, then let us take the questions. Any questions? It seems that Heather has a question. So Heather, we have only one mic.
I'm a snapper, but for those that don't use snaps, how can they use the new architecture with like Flatpaks?
Yes, this was one part of the talk which is not yet shown. The new architecture can naturally also used in classic Debian and RPM distributions. It is not required that you are snapping everything for it. You don't need an all snap distribution, and you do not need snap at all for the new architecture. You can also Debianize and RPMize a printer application, and you can do the same with cups. This will all appear too. But you think also about the other ways. Why does it not advance? Now it came back. Yes, yes. In Flatpak, the problem is you can only Flatpak GUI distributions because the kind of interfaces, the interfaces are the portals, which are more or less common dialogues. The application does. Yes, and so you cannot package system daemons. You cannot package system daemons. And one idea which I've worked out on the Linux Application Summit in Rovereto in several hallway sessions is that one could Docker cups. One could make a Docker package of cups, which is another form of encapsulated sandbox packaging. In these packages, one could run in a distribution which is a non-snap one, which does not support snap. And with this way, one can have a distribution independent packaging of system daemons there too, if cups and the printer applications are Docker containers. And so we can work this way, but it will take some time until I introduce it, because now I need too much time to finish cups filters 2.x, but I will look into that after cups filters 2.x. Any other questions?
We have a couple questions from online. So I'm just going to read one, and then maybe people can reach out to you afterwards to get answers to their questions. So the first one, or the only one, is from Paul. He's wondering if large format printers that are used for graphic design, architecture, etc., can be supported by cups due to him having a Canon Pro 200 large format printer that does not work well with Linux at all.
It depends now on the print. This depends fully on the printer manufacturer. I don't know what the printer manufacturers actually do. They could, this would be the ideal way, make them also driverless. I don't know whether they do it, but if they do it, this would be the ideal way, then they would just work. We have no hard limits on paper size or so. And if not, then we would need printer applications, ideally from the manufacturers. And for models which exist already for sometimes, several models are supported, for example, by Gutenprint, for which we have a printer application. And we will even get a better one by during this Google Summer of Code, I hope so. So they are as well covered as they were before. The switch over to the new architecture leaves it in the responsibility of the manufacturer to produce drivers or to make the printer driverless. This would be better, to make the printer driverless. As normal office printers are driverless already for more than 5 years, I assume that probably there are also some driverless large formats, but I don't really know.
Okay, great. Thank you, Till. And can some people email you if they have more questions? Or
Yes, yes, they can do it.
Great, fantastic.
Yes, they know my email.
Well, do you want to tell them?
Yes, it's very easy. It's till@linux.com.
Awesome. Thank you so much. Okay, that's the end of our talks for today. We'll see you back here at 9 a.m. tomorrow. And if you are signed up for the Women's GNOME Dinner, that's tonight. So check your email and we'll send you the details. Thanks, everyone.